Eh.
Do you have a favorite NFL team?
I'm from St. Louis, so no. I didn't like them when they were there. I mean, I watched The Greatest Show on Turf growing up with Kurt Warner, Isaac Bruce, all that, Marshall Faulk. That was pretty cool. I also got to witness Tom Brady becoming somebody. Some random dude playing for the Patriots. Like, what's going on here? Right? Going up against The Greatest Show on Turf, trying to win the Super Bowl again. Some dude. Some unknown quarterback. And then they barely win by a field goal. It's like, that's probably a fluke. And he becomes probably the greatest quarterback of all time. So, not a big Patriots fan. Not a big Tom Brady fan.
Yeah,
How about you, Blaze?
Colts fan.
Colts fan? I can accept that. Were you alive for the best years of Peyton Manning?
That's why I was like really young and I saw them on the Super Bowl and I wanted them to win.
Yeah.
And they lost that game.
Tony Dungy?
That was when Peyton Manning. They lost to the Saints.
Yeah.
But they beat the Bears in the Super Bowl.
This is true. I had a roommate in college that was a huge Colts fan.
You're from Indiana?
No. You're not from Indiana, are you?
No.
You just saw him in the Super Bowl and you're like, alright. Yeah, Peyton Manning is probably my favorite quarterback of all time. I don't know, maybe we'll start with some segment edition pasta. Maybe we'll start with one of these little puzzles. I don't want to do this. How do I want to do this? Hey, Chase. I'm going back and forth with what I want to do today. Hey, Macy.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Have a great day, Alicia.
That's quick. Start off with these ones. How about segment edition pasta last? Feels like last week. It was a couple days ago. Right, we were working on the square rectangle thing. Blah 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 blah. We figured out that you could break up some segments and put them back together. And when you put them back together, they're gonna be the same length, right? Ain't no big deal. Using that logic, talk about these segments. And we found out that last week it's kind of confusing to talk about which segments where when they're not labeled, right? And the way we're going to label them is something like this, maybe like A, B, C, and then this can be D, and this can be E. So we have segment AB, and if we want to talk about it, then we write AB, right? Something like that. Is that kind of hard to see for you guys? It probably is. I'll try to stick to markers, not pens. How would you solve a problem like Maria? I'll give you a chance to look at it while I take attendance. For those of you that have not met with me for portfolio conferences last Wednesday, you need to do that as soon as possible. I was online yesterday from 1:05 to 3:25. If you want me to do that again today, I can do that. We just got to get this done quickly. If you did not meet with me last Wednesday, not only do you need to meet with me this week, but you're also going to be meeting with me next Wednesday along with the 8A people, right? Because we got to get you caught up. So far, most of you have done it. Just a few that haven't, and the ones that have, it's been pretty good. And I should have links for everybody up now if you've met with me with your Google Meet, what we talked about, all that stuff. So if you want to go into Skyward and check that out, you can, or your parents can check it out and figure out, why you got the grade you did, or you can go in there and figure out what you might need to do better next time or make changes to, right? If you're like, oh, what do you say for this one thing? That's the way to go about it. Let's grab attendance. Don't see Paul, don't see Geraldine. I'm getting an email right now, so it might be one of them. Nope, just attendance for today. Let's take a look. See if anybody's on the list. Yep. Okay, cool. All right, first of all, A is directly above D, and E is directly above C. Is B necessarily in the middle? Looks like it could be, but again, calm down, it's just a drawing, right? Not drawn to scale. It's just that B is somewhere between A and C, and I just drew it there because why bother? I didn't break out a ruler or anything. Thank you, Macy. How can we figure out how long these are? What relationships do you notice? I think I threw letters on here and it's making you guys go, yeah, and that's fine. But don't focus on the letters, yeah. X plus 15, what do you mean? Okay, your boy's big on pronouns, don't get me wrong, but when you say it's, what do you mean by it's X plus 15? Well, what is X plus 15? What do you mean?
The whole thing.
Okay, so segment AC, its length, this whole thing is going to be X plus 15. Why X plus 15?
Because the between A and B is X plus 5,
Mm-hmm.
and in between B and C, 10.
Right, so basically what he's saying is that AB plus BC is going to give us AC, right? Anybody object to that logic? Right, little segment addition postulate. The pieces make up the whole thing, and when you add them together, you get the whole thing, right? No crazy thing there. And so when you add these together, you X plus 5 plus 10, which is just, there's a simpler way of writing that, right? X plus 15. So the whole thing going to be X plus 15. So what he did basically was say AB is the same thing as X plus 5. Now, I like to make a joke. This is a little algebra joke, right? So when you're doing algebra, it's really important that when you are doing substitution, which is what we just did, right? We took AB and we substituted the value X plus 5 because they are one and the same, right? Would you agree AB equals X plus 5, right? They're one and the same. That's what equal means. They are interchangeable, right? For instance, my first name is Derek, my last name is McAnally. You can call me Derek or Mac or whatever, it doesn't matter because they're interchangeable, right? It's going to get the same result. If they're interchangeable, whenever I have a sentence with Derek in it, you can replace that with Mac, and it's going to make just as much sense. Wherever I see an AB, I can replace it with X plus 5. No questions asked. Now, when you replace something, when you do substitution, you switch something out, it is important to always wrap it in parentheses. You guys know when you get a problem like this, like 2x minus 5 equals 12 or something, right? You want to plug in a number. Let's plug in -7. See how I wrapped it in parentheses because I switched it out? We call that, in the world I'm living in, practicing safe X. Whenever you plug something in, no matter where you plug it in, you're going to wrap it in parentheses, and this will prevent a lot of little mistakes that you might otherwise make. For instance, if you didn't wrap that in parentheses, you might think that's 2 minus 7. There are other cases where there's a double negative here and you get screwed up. Like, what if I give you the problem -x plus 5, and I tell you to plug in -7? You might think, okay, I plugged in -7. But you didn't, did you? Right? Because plugging in -7 is plugging in -7 to x, which is supposed to be negated. Remember, a negative means flip the sign. So take whatever you're plugging in and negate it. If I'm plugging in -7, right, I'm really going to get 7 out of it. So it's important when you plug it in to wrap it, because if you don't, it might make some mistakes, especially sign errors. So what I like to get in the habit of is whenever I switch something out, I wrap it in parentheses, even though there's not going to be any mistake there. Then I add BC, which you said was 10, which of course the parentheses are redundant, right? It's all addition. They were just organizational. So I can just go x plus 15. Cool, okay, awesome. What else do you see? What other relationships do you notice? If you're scared of the x's and stuff like that, don't worry about that. Look at the lines. Afton? Say again?
D and E is the same as A and C.
All right, so we have a statement, DE equals AC. Okay. There are two ways to write this. You can write it with the line over the top, and that's been like, hey, by the way, those are segments. If you don't write the line over the top, as long as we're in geometry world, we're not talking D times E here. We're talking about the value of DE, okay? So sometimes you'll see it without the line over the top because they're talking about how long it is. Other times you'll see it with the line because they're talking about the line itself. Like that line is perpendicular to this line, right? But the value of those lines usually don't have this guy. So DE equals AC. Why?
You said the notice that A is right, or B is right below A.
Mm-hmm. Like DE is kind of like a ruler that we're sticking up against this, right? They match up perfectly, so we know they're the same length. Same thing with this. We talked about pens the other day, right? You don't know how long these are. I don't know, I guess we could measure them. But if you put them next to each other and they line up, then you know for sure they're the same length. What that length is, no freaking clue. But I know they're the same. So that's solid logic. So DE and AC is the same. Guys, let's do a substitution. Because this is true, but we want to get some values out of this, right? DE is the same as AC. That's great. But DE is also the same as something else. What's something we can switch out for DE? Afton's running the show today. Hold on one second. Oh no, I don't have my. He's heating up. I don't have my monitors on. He's heating up. Are you stoked? Good. Now that we're stoked, Afton.
It could be A, B,
Okay, so AC is the same thing as AB plus BC,
yeah.
Right? So you can switch this out and you can say instead DE equals AB plus BC. That's fine, right? I put parentheses there to show that this whole thing used to be that, right? It's kind of organizational. You can never go wrong with parentheses, guys, when you do a substitution. Now, we know what AB plus BC is, right? Again, and we know it's AC. We already got that. So we can switch these out in there. But we already know AC is this, right? It's x plus 15. So I'm going to write that. X plus 15. Awesome. So DE is x plus 15. What else you got for me? Charlie. Yeah, it has to be, because look how DE is this, right? You can substitute those. So we can say 3x plus 3 equals x plus 15. Cool. This is the same as that, is all we're saying. Now, in theory, we should be able to solve for x, right? Do some PEMDAS action, move stuff around. First of all, let's talk about if this might have a solution or not. Right now we have take a number, times it by 3, and add 3. That's going to be the same as taking that number and adding 15. Does that sound crazy that they could be the same number? Or does that sound, sure, why not? What might be crazy, right? A number plus 12 equals a number minus 30, right? You can't have one going to the right and one going to the left and expect to end up in the same spot, right? That would be something that probably wouldn't have a solution. This could. So what do we do? How do we solve a problem like Maria? Yeah, go ahead, Afton. Okay, so when we do that, this is what's happening. And the reason we're allowed to do that is because as long as you do it to both sides, the problem shouldn't change, right? As long as you're fair, the problem shouldn't change. And now, before COVID, what I used to do is I'd find two dummies in the front row, right? Nerds. And I go, you ready? And they go, yeah, okay, sure. They had no idea what's happening. And I'd say, if you do it to one side, and I smack the one kid in the head, it's child abuse. But if you do it to both sides, it's algebra, and you can't be sued. This will hold up in court. So as long as we do it to both sides, it's fine. It's not illegal. We're all good. And what happens here? X minus x we can simplify, right? It becomes 0. It goes away, right? That's the illusion of it moving, right? X minus x is nothing, so it's now over here. Wow, amazing. It's not a trick. It's not, oh yeah, you just switch the signs and stuff. Yeah, that's algebra. No. Here's what's happening. We did the same thing to both sides. It shouldn't change the problem. It's just a different way of looking at it. It's like moving a Rubik's Cube around. We're not breaking it. We're not taking it apart and screwing it up. We're just changing the way we look at it. Same problem, different way of looking at it. Now I've got 3x minus x, which is 2x. And x minus x, which is 0. 0 plus 15 is just 15. Say it again? Oh, thank you very much. Thank you very much. That was not a purposeful mistake. So before we had 3 times a number plus 3 is the same thing as the number plus 15. Now we're saying that double that number plus 3 will be 15. That makes sense, right? There used to be 3 of those numbers, and they got us 1 of those numbers plus 15. Now there's 2 of those numbers, and that's going to get us just 15. You see how that makes sense, right? They cancel out because we don't need to pay attention to them. They're extraneous. So now what do we do? Yeah, go ahead, Carly. Yeah, subtract 3 from both sides, right? We call this the subtraction property of equality. In other words, if you have an equality, if you have an equal sign, you're allowed to do it to both sides, right? Something like that. 3 minus 3 is nothing, so we get 2x equals 12. So double the number equals 12. And that's a way of looking at this problem that I think you guys are already starting to be like, okay, I know what that is, right? Double of what is 12? 6, right? Because 2 times 6 is 12. If you wanted to figure that out, you could divide by 2. We're separating that 2 from the x, right? Before we were moving things around, moving things, right? And whenever you move stuff in algebra, there's only 2 things you can do. When you move something, you either add or subtract. That's it. Division and multiplication. Division is separation. So we want to separate the 2 from the x. See how they're being multiplied together, right? When you separate, that's division, right? You're not moving anything. I just separated the 2 from the x, and now we have 12 divided by 2, which is, of course, 6. Double the number is 12, so the number must be 6. So if x is 6, if we go back here and plug this in, that's going to be 11, yeah? 21 total. And if these are, in fact, the same, we should get 21 down here as well. 3 times 6, nice. 18. Add 321 as well. Well, how'd that happen?
I went to grab the water and I grabbed it too hard. Like I'm feasting on chocolate and got stuck in.
You're feasting on chocolate? Where'd you get the Hershey's bar, man?
One.
Nice.
Because I don't know, Miss Palmer gave me.
Oh yeah, Palmer nominated you for stuff.
Like, yeah, if you get something like a thing with the paper on it, you get
Right. Yeah. Boring, easy. Brennan's like, boring. Are you guys ready for a where are your gods now problem? I get it. It's easy. This is great. This is fine. Are you ready? Let me find you a juicy one that I gave out last year. Being figured out. Ooh! Ooh! These two, by the way, are lined up. This guy and this guy. They're lined up. Cool. My drawing's just terrible. Let's use blue. I'm going to say this whole thing right here is 19x minus 1. This thing is 14x. And this is 10. Let's give some labels to this. Carly, what's your favorite letter? A. Why is A your favorite letter? Okay, that's valid. Blaze, what's your favorite letter?
There?
Yeah.
B.
Wow, why is that?
Because my name starts with B.
That makes sense. Connor, what's your favorite letter? Oh, I knew it. Derek, what's your favorite letter? It's actually not. Crap. Brandon, what's your favorite vowel?
Oh.
C.
Joe, what's the grade you don't want to get in this class? Afton, what's the word you say before whiz?
G.
There you go. There were options there. There really were. He could have gone a lot of ways with that. Hi, Geraldine. I will mark you her. No Paul yet, I don't see. What's the in the German musical scale? You know, A, B, C, D, E, F, G, right? Musical notes. In the German musical scale, what's the letter they use for B flat? What?
B.
No, they don't. There's a B. Yeah, I seen that Vine.
Yeah.
It's H. I don't know why, but they do. They use H for B flat.
I didn't know that.
Oh, speaking of which. Does my middle name start with J? Very good, class. We've learned so much today. Okay. What do you notice? What do you see, Lottie? By the way, this much is that. Okay. Just so we're clear. What relationships do you notice? Let's just start writing stuff down. Write it down. YLC. Blaze is having a great time.
I have two middle names.
You do? Is it your actual middle name, or is it just something your like your friends call you?
No.
Okay.
Two, like James.
Raymond James. Ray Jimmy. I like it. Blaze Ray Jimmy Hicks.
I like my grandpa's name.
That's dope. He has two names?
No. My great grandpa on one side and my grandpa on the other.
Oh, gotcha. Wow. Raymond Jimmy. You know what I like to do when I go to Jimmy John's? I like to call it James Jonathan. Put my pinky up while I'm eating the sandwich. Y'all like James Jonathan? No? You had their veggie subs? Do you like peppers?
I'm thinking which one. I don't know which.
This is a tough question. You better think about this real thoroughly. If you give me the wrong answer, I swear to God, Afton.
What's the sandwich shop in Clinton? Not Jimmy John's? I don't know, but they have way too much lettuce on everything. Like piles of lettuce.
Have you got the Travis Scott burger?
I have not, no. Is it dope?
I don't know.
Blaze is just cracking himself up today. He's like, I got two middle names. Man. And I was worried we wouldn't have a funny kid in the class this year. Whew. Thanks, Blaze. Okay. You can be whatever you want to be. Live your dreams. What relationships do you notice here? First of all, what's kind of weird about this one versus the last one?
They're not lined up.
What do you mean they're not lined up?
straight down like that.
We got some overlap, don't we? Juicy. Juicy. I also want to draw to your attention this. Those are lined up, just in case you were worried. I want to figure out the length of AD. When you're given a tough problem, make an easier one. Just start finding relationships. Make connections. What I like about this problem is there's a lot to look at, and so it's distracting. And you have to find the stuff that's not, you don't have to be like, oh, that's not useful. Like, you know how word problems will be like talking all the time and distracting you with stuff, right? Kind of like I'm doing right now, but you don't realize I'm doing that. You just think I'm talking and teaching, but in reality, I'm distracting you. And you know how word problems do that, and they give you a bunch of extra information, and you have to find the good information? That's not what we're doing here, okay? It's all valuable. Did that help? I love messing things up. What connections do you see? Go ahead.
A and B are the same as O and F.
AD equals OF. God, we were so close, guys. We were so close. Yo, 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 Parker, baby. What's up? We're looking for connections. We're trying to solve a problem like Maria. We're trying to find the length of AD. We've got some overlap here. B and G are lined up. C and J are lined up. What connections do you see? Carly! I'm sorry, say it again. And 8x. What do you mean 8x? Okay, so check it out. What she's saying is that BD is the same as GH. So far, you guys follow her logic? BD and GH the same? We cool with that? Yeah? Okay, cool. So that's valid. We agree. And then you're saying that GH is 14, right? 14x. And BD is 6x plus what? Sorry, we're running out of room here. Oh, that's terrible. Yikes, that's hard to see. So BD is 6x plus what? We don't know, right? What can we call it? Give it a name. How about Jimmy Ray? Is it Ray Jimmy or Jimmy Ray? Ray Jimmy? Ray James? I like it. It's like LeBron James is like lesser known brother. Ray. How we call it CD? Right? Because that's what we're going to find, right? That's what she's looking for. So how did she figure out that this is 8x? Well, some amount, six x's plus, that's a lot of x's. Anybody have more than 6 x's in here? Guys, in algebra, terrible idea in real life, great idea in algebra. We're going to get our x's together. We need to get that x with that x. You never want to get your x's together, except in algebra. I'm going to subtract it, right? And what we're going to get is that 6x plus 8x would have gotten us 14x. And that's where she's getting that from. 14 minus 6, I don't know, for some reason that's hard, but like 14 minus 7. Oh, 7. So 14 minus 6 is 8, right? Something like that. So that's 8x. Okay. What else you got for me? Now, did Carly answer the question that I asked initially? No. But that's not the point, right? We're learning more about the problem. Maybe we'll answer this question, maybe we won't, right? And the more you learn about it, the easier the problem gets, because the more you know, right? The more you know. What does Google have to say? Any advice? Oh, damn. Parker, you got any insight? I want some Jimmy John's real bad. You get peppers on your sandwiches? I'm doing the thing where I distract you again.
Banana peppers.
A, C, I, J are the same. Okay. AC equals IJ. We agree? Okay. So what are we gonna do with that? Can we do anything with that? You what?
Cut it in half.
Cut in half? Like a sandwich? Why are we cutting in half? And what are we cutting in half? What's it? IJ, cut it in half and it's 5? Oh, are you saying this is 5 and that's 5? That would be very convenient if B was in a specific spot. It is in a specific spot here, but is this? Not necessarily, right? 5.5. 5.5 and 4.5. Not necessarily. We're not sure where B hits on here. It looks like it could be, and I see why that is. I'm glad you brought that up because this is lined up because I told you, but we don't know that it drops down further. Good thought. No, my brain was thrown into a pizza oven and hand tossed by your boy COVID. Oh, sorry. I made homemade pizza the other night. DJ COVID in the house. Wicka, wicka, wicka. Let's get this party started. All right. It's not funny. What's wrong with you? All right, AC and IJ. They're lined up. I agree. What can we do with that? Can't be half. But there is something to it. We're focused on this, right? Sometimes it helps to ignore the stuff you're not looking at. What do you notice? I love how Carly did this over here, and you're like, oh yeah, that's fine. 6x and 14x and whatever this is, right? That's fine. And it's because they all had x's in them. But as soon as we go over here, that same logic just flies out your brain. And partly it's because I'm distracting you, and I'm really good at it. Remember I did the coughing thing? That was funny. Why? What? How do you know that's the halfway point?
I don't know, it looks like that.
It looks like it. I need to play this.
Take it easy, it's just a drawing.
That one's extra loud. Sorry. You know what episode that's from, right? Doodle Bob?
Yeah.
Noimy, yay. Finland! You watch SpongeBob, Jocelyn? Yeah, you do.
Miss Carly?
Carly, probably not. She's just like, oh yeah, I watch that show. I like it. My parents let me watch it. Yep. Sure. Sure, with an H. O-U-O-R-E. S-H-O-R-E. Sure. I'm good at distracting you. Don't focus on the values. Focus on the segments. What relationships do you see? You're getting stuck because you see X's. What relationships do you notice? Carly? AC is 10? How do you know that? I think we agree. Do we all agree that AC is the same thing as IJ? We do, right? So AC is something, right? But IJ is 10, so we can say AC is 10, right? That's logical. You following me? Okay. But what is AC? How can we break that down? What is AC? I'm not asking how long it is. We don't know that yet. Tell me the relationships that AC has. What's another way to think about AC? Another way to look at it. Perspective is everything, guys. That's what math is all about. You're trying to solve stuff because you've been told that's how math works, but that's not true. It's about seeing stuff, and seeing it is the hard part. So don't feel bad if you don't. You guys ever done those optical illusions with your grandpa? Right? A little piece of paper, and they're like, look at this, there's a boat. And you're like, what? And then you put your nose up to it and like pull it back and you see the boat pop out. You ever done one of those? Those were a huge thing in the 90s. I'm trying to find one that I give you guys. But once you see it, it's like, oh, you can't unsee it. Right? But until you do, you feel like an idiot. But you shouldn't. Because it doesn't make you dumb, it just means you haven't seen it yet. So Carly, what do you see? Boom. Right? AC, we're substituting this for it. Now, what do you know about BC and AB? Well, you don't know much about AB, right? BC is 6x. Ah. Now, wait a minute. We did something over here and everything went away and it was nice. We got our x's together. We're not going to get our x's together here, right? But we want to know what AB is, don't we? Because we know what AB is, we can add these all up and we can get AD. What is AB? 4? Why? Oops. AB is 4. 4 plus 6x equals 10. Agree or disagree? She's right on the basic concept because she's saying, look, 4 and 6 makes 10, but what's the problem here? It's apples to oranges. Do you see what I'm saying? We're talking about 4 versus 6 x's. You see what I'm saying? It could either be 10 x's, but this isn't x's, right? Or it could be just straight up 10, but this guy's not straight up 10. Do you see the difference? Now, the reason you're inclined to say that is because it's kind of what we did over here, right? See how these guys are both x's? I set you up for that. That was the play the whole time. See, when I talk about this stuff and I distract you, it's in order to make you forget about what you've done before, so I can ask the same question twice and see if you actually knew what you were talking about or if you just got lucky one time. Now, because I'm asking different people, right, that doesn't really count, but I like doing that. So not 4. It's going to be whatever 10 minus 6x is, right? Do we agree with that? Now, what is that? You say 4, you say 4x or something, right? We don't know. We can't do anything with that. Did we see that? It's stuck the way it is. There's apples and oranges here. You smell what's happening? So this is what AB is. And you're like, yeah, that's not a nice number, but it's okay. This wasn't either. Remember, it's a relationship. It's 8 times whatever the number is. This is just 10 minus whatever 6 times the number is. It's okay. It's weird, but it's okay. That's what we say about most of you. All right. All the way across, we add them up, we get AD, correct? So AD is going to be AB plus BC plus CD, and we can just substitute those right away, right? This plus this plus this, the 3 segments, right? That's AD. Okay, great, but we need something else. I want you to take a look at this. Write about what we did in our journal, the lining stuff up. Talk about how you thought at one point that this was half and why it can't be necessarily, right? It might be, but it might not be. Talk about how you thought this was going to be 4, but it can't be and why, okay? And then if you can, try to solve the rest of it. Nice job today. Blaze, everyone but you had a really successful day. You just spilled water on my floor.
Yeah.
Can I spray?
Yes. Wait, you want to spray?
Yeah, I'll spray.
Sorry, I have a bottle. I win. This is the one perk of my job.
Alrighty. Hi, Katie. Come. Come. What are you? Oh, Katie's gonna beat me up.
Katie picking a fight. Katie, pick on someone you can beat up, okay? I don't want to clean up that mess. I changed my mind about what we're doing today at last minute, so the name of the video is kind of off, so that's okay. look like Anakin Skywalker as a kid. Exactly me. It's all around. I love it. I hate fans. This guy doesn't know.
I don't know if it's an insult or a compliment.
Leonardo da Vinci? What is the Vinci thing? I need to know.
I'll show you.
I don't know if I want to know the answer. I regret asking this question. Corinne!
Woo!
You guys notice the blue?
Yeah.
Awesome.
It's like teal because it's fresh
It does get everywhere. Amazing writing. I went and paid money to see that film. I'll send it to you on Insta. Okay, I appreciate that. I swear to God, if it's this year's Stinky, I'm gonna be upset. If I hear Stinky one more time in my life. How y'all doing? Here, I'll utilize my my new camera. None of you guys have like visual impairments or like will freak out if this thing twitches, will you? We'll find out. And now you got a spot where you can do all your TikTok dances. Okay? Speaking of which, Taylor Swanstrom and Shelby Belcher will be doing a TikTok dance. They did it on Friday. Haley's here, wonderful. Like I said, I hope you don't freak out because of the twitching and the glitching and all that's going on here. One of those kids divert your eyes, and I'll get a new camera by next week from the movie. I don't know if mine was just practice. Figured. Gotta start walking around some more, you know what I mean? COVID's just hitting me hard. Sitting at this chair, not good for me. Not right for me. All right, so today, yesterday, a couple days ago, feels like last week, we talked about segment addition postulate, right? The idea that you can take a thing and break it into its pieces and put them back together and it'll be the same length. Not shocking to anybody. Wonderful. I'm going to give you a problem that's not so bad, and then you're going to think you understand it, and then I'm going to give you a problem that's going to make you cry, and you're going to go, where are my gods? Why have you forsaken me? Remember, it's just a drawing. That point, is that necessarily the middle? No, right? Doesn't have to be. It's just a drawing. Katie, what's your favorite vowel? What's your favorite vowel? Nope. Let's see. I'm thinking. Baron, what's your second favorite grade? Your second favorite grade? Letter grade.
Oh, okay.
Good. We'll put C there. What's that one Vine? He's like, how do you spell your name? And
B.
give it to me. Who can recite it?
My name's Michael with a B.
Wait. Where's the B? And you say,
There's a B?
thank you.
That's my favorite part.
I love it. I love it. I need to get that on the soundboard. We'll do attendance in a second. Derek, what's your favorite letter? D. Just kidding, it's not, but we'll say it is. And then, Olivia, what's your second favorite vowel?
Oh.
This is the second class in a row someone's done that, and it just disappoints me. All right. What relationships do you notice here, first off? Actually, no. It's not ready. It's not ready. I want to confuse you a little bit. I'm going to write a bunch of stuff on here that's not going to matter, but you're going to think it matters anyway because your eyes are going to be drawn to it because you're used to doing math a certain way. Okay, what kind of relationships do you see? While you think about that, I'm going to take Tendi. Haley's here. Ooh, Haley got the new profile picture. Jaden's here. Sarah's here. Blake is here. Jace is here. Ethan is here. Whom are we missing? Whom indeed? I do not see Jaden. I do not see Nathaniel. Do not see Sarah. No, I see Sarah. Okay, we're good. We're good. So Jade and Nathaniel, if you're friends with them, give them a text. Tell them to wake up and check in so they can get their credit for today or whatever. Anyway. Excuse me. I read your post about education a little bit. Actually, no, I didn't. I saw the title. I didn't read it yet, but I'm excited to read it. And my first reaction was, did we just become best friends? You know, that Step Brothers? You like that movie? You probably don't. It's one of those movies you watch, like Napoleon Dynamite. Does anybody know what Napoleon Dynamite is? Okay, you do? See, that's shocking. It's a terrible movie. It is a bad movie.
No, it isn't.
However, you will quote it the rest of your life. You will. You will.
Meg, I'd like to talk to you about that after class.
Okay. What do you notice? Yo, what's up? Parallel lines. Oh my God. Robin Thicke or something like that, right? The song? That was awful.
Oh.
Please don't bring that up. What I think she means is that these lines are both running in the same direction. Railroad tracks, right? And what's cool is that the A and the D are like right above each other, and so is the C and the O. God. Amazing. You're right. What else do you notice? Corinne!
X plus 5 plus 10 equals 3 plus...
That's an X. Sorry, I know it looks like my Z's. I need to stop doing my cursive X's. Anybody have cursive X's in here? Those are the worst kind of X's. Like the worst kind of X. Okay, so Corinne just said something. Corinne, why is that true? Why is X plus 5 plus 10 going to equal this? They're the same length, right? So in other words, she's saying AB, this line segment, plus BC, the other line segment, is going to equal DO. Oh my God. All right. Do we agree with this idea, right? Segment addition postulate says AB and BC make up AC, right? And AC equals DO. That's kind of what Marissa was saying, right? We cool with that? We switched out AC for its parts. Totally valid. Whenever you do that, wrap it in parentheses. There's a joke to be made there. They don't know. Now, when we switch stuff out and we substitute, right? What we're saying is that they're interchangeable. So for instance, my first name is Derek. My last name is McAnally. You can call me Mac or Derek in a sentence. Wherever you see Derek, you can replace it with Mac, vice versa, right? It'll mean the same thing, right? AB is the same as what? What is AB the same as? Mika! Were you just like, no, don't call on me? Because this is like the wrong motion to make if you don't want to be called on. That's like the opposite of what you want to do. Don't call on me, please. Please don't. Okay. I'll know from now on. Mika raises her hand. Don't call on her. Oh, Mika's not raising her hand. Mika, what did you want to say? X plus 5? AB is X plus 5. They're one and the same. They're interchangeable. That's what an equal sign means, right? So AB is the same thing as X plus 5. Oh, I did the thing again where I made the cursive X. I'm sorry. And then BC. What's BC the same as? 10. I'm blowing everybody's mind here. I told you, this is going to be the one where you go, oh my God. Chipotle. Chipotle is my life. Right? And again, the parentheses are just organizational, showing you that this used to be that, vice versa, right? Now it's all addition. Do I need parentheses? No. I'm just doing it so you can see where it came from, you know? Origin. Everybody loves a good origin story. X plus 5 plus 10, there's an easier way to write that, correct? What's an easier way to write that? Take a number, add 5, then add 10. What's that the same as? Take a number and add 15. All right, terrible idea in real life, great idea in math. We're going to do something called getting your X's together. Again, terrible idea. Do not do this in real life, okay? It is only a good idea in math. How do we get our X's together? Yeah. Yeah, right. There's this thing where if you have an equality, as long as you do it to both sides, it's fine. No, normally, when it's non-COVID, I pick two dummies that sit in the front, and I slap one like this in the head, and they go, ow! And I go, see, this is child abuse. And then I smack both of them in the head, and I say, this is algebra. Again, as long as you do it to both sides, it's fine. It's totally legal. This will hold up in court. So what we're going to do is subtract x, is that what you said? Okay. To both sides. And the reason this works is because, again, algebra, right? It's just how the law works, man. When you have an equality, if you add or subtract or divide or multiply everything on both sides, totally fine. It's not going to change the problem. It's a different way of looking at it. It's like a Rubik's Cube. When I turn it, I'm not changing the Rubik's Cube at all. I'm just looking at it in a different way. It's a change of perspective. We're not changing the problem. If we could do that, we'd be like, replace this with 2 plus 2. I win. I know that one. It's 4, right? We're keeping the problem the same. We're just looking at it differently. And how are we looking at it differently? Well, when we do x minus x, we get 0. 0 and 15 makes 15. Here, 3x and x subtracted gets us 2x's, right? 1 less x. We like that. Now, think about what this is saying. Before we had a number plus 15 is the same as 3 times that number plus 3. Another way of saying that is, look, I can ignore an x here and an x here, right? I don't need to factor those in. If I told you, hey, I've got 2 numbers in my head, okay? It's 22 and 22. Now add 5 to both those numbers. Do you need to think about that for both of them individually? No, you don't, right? It's the same thing. We can ignore it. There's an x there and an x there. Why am I adding the same thing to both sides? I can remove one of those x's and not think about it, right? That's the logic. So now we got our x's together. Now we want to get x alone. Right? So you can make moves, get back in, right? I need you! Come back, please! You know who I'm talking about. That special someone. You're thinking about him right now. Yep. High schoolers are awkward. How do you solve a problem like Maria? Girl, you could do better. You could, okay? Move on. How do you solve a problem like Maria? Well, isn't the idea that we're going to double a number and add 3 and get 15? So if we didn't add 3 to that number, right? If we didn't add 3 to this number, what would we get? We wouldn't get 15. What would we get? I'm asking a weird question, okay? I know you know how to do this. I know how to do PEMDAS, okay? That's fine. I want to think about it for a second. Doubling that number and adding 3 gets you 15. So if we didn't add 3, if we just doubled that number, what number would we get? If we didn't add 3 to this, what will we get? What do we get before we add 3? When we add 3, we get 15. Yeah. Why 6? Ooh, you're thinking way ahead. You're like, 2 times 6 is 12, and then we add 3 and we get 15. That's true. So even if we didn't know that this was 12, right? Wouldn't we know that it has to be? Because after we add 3 to it, we get 15. So something plus 3 is 15, right? What plus 3 is 15? 12. So something plus 3 is 15, so something must be 12. And then something doubled is 12. So it must be 6. I mean, what we did here was PEMDAS, right? We just subtracted 3 from both sides, because you're supposed to, right? And then we divided by 2 to everything on both sides, and we got this. But, like, that requires me to think in my head, but the other way doesn't. Something plus 3 is 15. Okay, that's easy. 12. Something doubled is 12. 6. I don't know. I'm not saying it's a better way of doing it. I just like thinking about what we're doing while we do it. So x is 6, which means this is 11, that's 10, this is 21, yeah? You're bored. Let's move on. Do what?
Yes.
Which part?
All of it?
So, we said AC and DO are the same thing. You agree?
Yeah.
Okay, cool.
I don't know why that's algebra. I don't know why.
Oh, don't worry about the algebra so much. We're just finding relationships here. That's kind of why I zoomed through the algebra, okay? But do you agree the relationship between here and here is the same? Okay, so we wrote that down. Then we said, well, isn't AC just these two added together? AB and BC, right? That's segment addition postulate. The pieces add up to the whole. What is AB but x plus 5? Isn't AB x plus 5? And isn't BC 10? So instead of AB plus BC, we have x plus 5 plus 10. Same thing, right? There's a different way of saying it. Potato, potato. These two added together, right? AB and BC is the same thing as DO, correct? Yes? Could be DE, but it's not. AB is the same thing as x plus 5, and BC is the same thing as 10. So instead of saying AB plus BC, we can just say x plus 5 plus 10 equals DO, right? And DO is 3x plus 3. We get up to here. X plus 5 plus 10. Take a number, add 5, then add 10. Well, why not just add 15 all at once, right? And then here, we got our x's together by subtracting x to both sides. That's the algebra thing, right? We subtracted x from both sides. We had 3 x's here, 1 x there. When we remove an x, we now have 2 x's, which is 1 less x. We like that. We like that. And then subtract 3 divided by 2. We're going to get used to that, don't worry. It's been a while since you've had algebra. We didn't really do any algebra last year, which is kind of I regret that. It's one of my biggest regrets. Well,
failed algebra to begin.
Yikes. Okay, well, we'll figure it out. This is what I was going to do, but I don't want to do that. I want to do this one. Are you ready? Okay. You say you're ready, but they never are. Let me make sure I'm doing the problem correctly. I want to do the same one we did before with the other kids. Now, question. Are these 3 segments equal? Not necessarily, right? Yeah, what's up? I think it's because of the air conditioning. But that's just a guess. I'm not a professional.
Okay, thanks.
No problem. All right. Now, these do line up, just to be clear. We cool with that? Those 2 dots do line up. And then these dots line up. And these dots line up. Cool? Things that line up will line up. You can assume that. Do we know that it's cut into thirds? No, I just put some dots down, man. Okay? I don't know. I didn't get out a ruler. Ain't nobody got time for that. I'm going to tell you that this segment here is 6x. I'm going to tell you this whole segment here is 19x minus 1. This whole segment here is 14x. And this segment here is 10. Now, what you're going to do in your little smooth brains is you're going to start focusing on the letters and the numbers, and you're going to go, oh my God, algebra, what's the answer? Look, this is kind of a difficult problem. It's not hard, necessarily to the point where you're going to be like, I can't figure it out. We'll be okay. But if you focus on how do I figure out how long this segment is right here, right off the bat, you're going to get lost. I want to know how long this segment is. That's the question I want answered. Segment AD, what does it equal, right? And I'm not trusting you guys with the rest of these. Wait, we don't want to use H. Let's use K. H and I look the same if you turn them. And K's for Katie. Yes. All right. So we want to figure out how long this bad boy is, right? And right off the bat, you're stumped. When life gives you lemons, you find a new god. No, you find a simpler problem. What relationships do you see here? Katie. Ooh, great question. So she's saying I and J is the same as AC. Do we agree with that? So IJ equals AC. Laura Lee, you dig? IJ, AC, they're the same, right? Okay, cool. No one's objecting to that? Okay, then we'll move on. Trust no one, but if we agree. And then she's saying, well, wait a minute. AC, isn't AC the same thing as AB and BC put together? We agree with that? Campbell's like, boring. Why are you being so mean to Katie? So AC is this idea. That's why I wrapped it in parentheses. It's AB plus BC. You dig? And then her last thing is she's saying, well, IJ is the same as 10. And AB, we don't know. But BC we know is 6x, right? And then what'd you say? What do you think? So she's just focusing over here. Ignore this guy. We're just focusing here and here. 10 will be the same thing as AC. And AC is just going to be 6x plus whatever AB is, right? That's what she's saying down here. So she's trying to figure out AB. Uh-oh. What's wrong? Why'd you lose all your steam? Don't call or do call? Okay. I'm confused. It's so much easier if you just raise your hand when I want to call on you. We should just do that. It's at least 3? Why at least 3, Parker? Well, Parker's typing. Anybody else have something to say? Yeah. Say that again. Gotcha. We agree AD and EF are the same. There's something. He's just pointing out what he sees. Might not have to do anything with this necessarily. Now what if 10 equals AB plus 6? Not 6x, but just 6. Well, Katie would subtract 6, and she'd be like, okay, then AB must be 4. In other words, right, something plus 6 is 10. Right, that something would be 4. But she paused because she realized there's an x there. See how this is like apples and oranges, x's and a regular number? We have 6 x's, then we have 10 of something else. If I tell you I have 6 ducks and 10 apples, does that mean I have 16 ducks? No. Does it mean I have 16 apples? No, you have 6 ducks and 10 apples. The two can't combine. Do we agree? So we have apples and oranges here. We can't combine them. That's true. Think about it. If this were 10 and this was 6, you'd subtract them and get this as 4, yeah? Makes sense. Well, what this is going to be is whatever happens when you subtract those two, right? We agree with that? Right. Ignore the letters, or ignore the numbers, right? This minus this much will get you this. Agreed? In other words, IJ minus BC will get you AB. Right? Big guy minus small guy gets you the other guy. IJ we know is 10. BC we know is 6x. And AB we don't know. In other words, subtract 6 to both sides, right? That's what AB is. Do we know any more about it? No. That's okay. That's okay. It follows the same logic though, right? This minus this will get you that. We cool with that? What is it? It's this bunch of junk. I don't know. That's all we know for now. Again, we're just finding relationships here. It is completely unrelated to this question. AD and EF are the same. That's what Theron was saying. Okay. What else do you see, Katie?
B, and K are the same.
Okay, let's break that down. First off, she says, her first assertion is that BD and GK are the same. Agree or disagree? BD and GK. Same? Okay. Then we'll write that down. Write that down, write that down. Okay. And then she's saying, well, BD is really just two pieces. So instead of writing BD, I'm going to write BC plus CD. It's a substitution. She's switching them out. They're interchangeable. BD is the same thing as these two put together. We cool with that? Yeah? Okay. Well, we want to get some values here. So eventually we need to switch out ideas, segments, for their values. What's the value of BC? 6x. What's the value of CD? We don't know. What's the value of GK? $14x. Don't forget your x's, okay? Stalk them on Instagram. Katie tends to forget her x's. She says 6 plus CD equals 14. Now questions, are we talking apples and oranges here, and apples and apples? What are we doing? It's an analogy. This is 6 x's and 14 x's. Are we both talking about x's? Good. We got some gossip. These things can go together. We're not changing the subject. Marissa, what are you smiling about? Yeah, you're thinking about your ex, aren't you? I'm sorry. Is this traumatic? Should we stop talking about, should we switch to Y? Would that be better for you all? Okay, now you're smiling. No happiness in math class! Okay, Katie, what? Yeah, and that would give you an easy answer to figure out what's going on. That's a method for figuring out CD, right? You can also just think about it, but that's valid, right? 6x plus how many x's is 14x's? I'll ask an easier question. If you had 7 x's, and some of you do, okay? Some of you guys were dating in kindergarten, right? If you had 7 x's, how many more x's would you need to have the same x's as Marissa? 14. If you had 7, you'd need 7 more, right? So if you had 6, how many more would you need? 8 more, right? Yeah, you can subtract 6x from both sides. That's totally valid, right? You do this to both sides. 6x minus 6x is nothing. Got rid of your x's, hooray. So there's just CD over here. And then 14x's minus 6x's is just 8x's. Literally, it's like having 6 watermelons and 14 watermelons. When you subtract them, you get 8 watermelons. Don't forget your units, right? Don't forget your x's, stalk them on Instagram. So CD's 8x. Okay. Now what? We want to figure out the whole length of AD. What's AD the same as? Well, Theron already said it's the same as EF, yeah? We dig? Okay. Awesome, let's do some substitutions. What's EF the same as? EF is what? Kimball, why are you sleepy? Okay. You guys all have a good remote Wednesday yesterday?
No.
No? Is it like the worst day of the week? But you get to stay home. It's really the worst? That's so interesting. We need to talk about this. Yeah. Well, it's because you're home, right?
You still have like work and everything.
Yeah, I know. It's the same logic as, you're the advanced kids. Why can't you do this? Right? I hear you. I hear you. What is EF the same as? What's another thing that EF is equal to? Well, it's equal to the idea of AD, right? But what else is it equal to? You're thinking too hard. Oh my God. Thank you. And Laura Lee's like, I don't know algebra, but you know relationships. You know relationships. You know how they are, right? Boys and girls and, all kinds of stuff. They asked me to sub for health class once. It was amazing. All right. It was the banana day. All right. That was traumatic for everyone. All right. What's AD the same as? Stop looking at me. God. You guys had that one kid that you grew up with, like in 4th grade or whatever, and they get mad when people look at them. Stop it! There's always one. Marissa. She's like, that me. It me. No one look at Marissa. Danny! She doesn't like it. She's gonna go crazy. What is AD the same as? What's another way to think of AD? I had a chemistry teacher named Mr. Pollen. And when he retired, he was like the perfect scientist. He had like white hair, big glasses, and on his lunch breaks, he wouldn't take lunch. He would actually go do Meals on Wheels and deliver meals to everybody in the community. He's a very wonderful man. And I remember one day his brain just kind of broke. He was talking about like atoms and like electrons, and he was just like, and the pieces, the pieces. I was like, this man needs a break. The pieces, AD. What the pieces? The pieces. What are the pieces? What are the pieces? Are you doing the Mika thing, or are you raising your hand? I'm so confused. We had a system, Mika. Yes. So you're telling me AB is one piece, right? No anime fans in here. BC and CD. It's the same thing as AD. Well, what is AB? It's 10 minus 6x. I'm showing my work and my logic here, right? Isn't AB the same thing as 10 minus 6x, right? And BC is the same. You can trust me on this. Here, as 6x, and CD is the same as 8x, and that's gonna be the same as AD, which we know is 19x minus 1, right? That's what we found out earlier. So now we're talking about values. Now we're talking about x, baby. Just like health class all over again. Now what? How do you solve a problem like Maria? Do we need the parentheses? It's all just addition and subtraction. Relax, man. So we've got a 10x, or 10, a negative 6x, a 6x, and an 8x, and a 19x, and a minus 1. Right? All different ideas. What do you notice? Katie. Yeah, right. Subtracting 6x and adding 6x. Let's not say we did, right? This is just the same thing as taking 10 and 8x and never doing either of these, right? Because it's just a waste of time. Why subtract something and then add it back? You're just going to get where you were before, right? So now we're here. We're going to do something that's a terrible idea in real life, great idea in math. What are we going to do? Marissa, what are we going to do? It's a terrible idea in real life, but a great idea in math. What are we going to get together? Should be Y. You should be mine. Y'all like Taylor Swift? No? You like that new album that came out?
It kind of sucks.
What are you talking about? Paper Rings is a jam.
I listened to it like all the way through, and I listened
For real?
to it multiple times. I tried to like it.
Okay, so what's wrong with you?
What's wrong with it? There's a lot wrong with it.
Okay, it's her, she.
Let's talk about the album, not her.
Okay, we're gonna get our X's together. I'm gonna subtract the 8x. You do you. You can subtract the 19x. You can even do the regular numbers first. No one cares. No one cares. So I'm just gonna stop talking about it and do it. We've got 10 equals 19x's minus 8x's. How many x's do you have? Not as many as Marissa, but how many? 11. Isn't this fun? Okay. 11 times a number minus 1 is 10. Okay, stop. Something minus 1 is 10. What is it? 11. So something, which we said was this, is 11. Something times 11 is 11. X has to be 1. Do you agree with my logic? Right. And you could do PEMDAS. That's what we did, right? We added 1 to both sides, and we got 11, and this was nothing. And then we divided by 11 to every, and we got 1. Okay. Right? Or you just like stop and think, stop, get some help, right? Michael Jordan, we need that on here. Can you remind me to get that on there? Marissa, you know what I'm talking about? Michael Jordan? Stop, get some help. You never seen that? Katie, have you seen it? Okay, thank you, Katie. Remind me to get it on the soundboard. So X is 1. Wonderful. So if X is 1, we've got 6 here, we've got 8 there. What's this? 10 minus 6? Katie was right. It's 4. And in total length, what do we have? How would you add 4, 6, and 8 together? What would be your strategy?
I don't know.
What would you add first? The 4, the 6, the 8, the what?
I just go in order.
Okay, 4 and 6 gets you 10. That's pretty easy. And then add 8, 18. Okay. Did I blow your mind? What just happened there? Did we just have this?
Oh, Lord.
It was 4, 6, and 8, Theron. Good God. I don't know what you're talking about. Yes, it is. When you go about solving this problem, it's really difficult if you just try to go for the answer right away. But if you break it down, okay, I noticed that AD is the same as EF. Well, I can use that later, right? All this should add up to 19x minus 1. If I knew what this is, I can win, right? I know that all of this should be 10. So this must be whatever 10 minus 6x is. Do you see how that works? Right? What is this? Well, it's whatever 10 minus 6x is. So that's what I write. How much is this? Well, it's whatever 14x minus 6x would be, right? Which in this case, we can simplify. It's just 8x, right? And now we've got a plan. It's all about the pieces. The pieces. I think Mr. Pollen is still alive. I'm not sure. We should check on him.
If I ever get like a B or something, I think that's
There's a bee? I'm sorry, what were you saying?
if I ever get like a B.
Mr. Pollen? Okay, for the record, this man is Jim. His name is Jim Pollen, and it's spelled like this.
Oh.
But that's cute. Mr. Pollen, the bee.
Even though all of them are girls.
Is that true?
Yeah, same thing with ants.
Wait a minute. I thought there was a queen bee.
Yeah. And then all the
If they're all girls, does life find a way? Is this like Jurassic Park?
It's kind of weird because like
We accept all kinds.
here's how it is with ants. Like once a year they'll like produce male and female like queens and kings will go out and breed. They'll just drop their wings. The females will eat the males and then go and
Very normal practice, just like humans. Okay. But that's how the ants do, huh?
There was just like a nuptial flight, I think.
A nuptial flight?
Yes.
Is that like eloping?
Sort of, yeah. Pretty
Interesting.
much.
Well, good for them. You know what I mean?
Love ants.
Get out of here. Make your own little problem.
Well, speaking of that, I did make a problem because
Don't make your own little problem. Wait, no, math class. We're good. Bye. I get confused with the advice in math class. You want to make little problems, but when, okay.
yeah, no, I went out and I got a
Are you winning, son? Oh, we are.
test tube setups with the ants and all.
Test tube setups?
Yeah, and you can sell them. People buy
Very,
the
like, in
ants.
vitro? Is that what we're talking about?
Sort of.
A pair of what?
No,
What are hey dudes?
Oh, stop. No,
Those?
Don't do it.
Yes, they
Okay.
are so comfy.
I literally just said, what are those?
They are so comfy.
Okay.
They're so comfy.
Are they like Crocs for people that care how they look?
No, they're
Crocs
like,
are status. I have that video with the really lightweight. And they have like
I don't like spending money on shoes though, because like that means I'm not spending money on other things. How expensive? $16?
No way.
Corinne, what do you think I'm made of? Money? What? You did? Let me see. Sophie. Forgot it. Mine. You spray down those desks. You didn't even know. Geneva, how do you get your hair to do that? To do that. Incredible. Absolutely incredible. When I grow my hair out, it just like sits on my head, no volume. It's awful. So no product, not like rocking the Tresemme or something. Anybody see Skylar today? No. You are all liars. That's probably true.
It's back on Lois here.
That's pretty true. All right. I changed my mind on what we're taking a look at today. Throwing an audible. Throwing an audible. Calling an audible. These are hard. My second hour was just in a funk today. It was a remote Wednesday. Not very good.
We even have anything yesterday?
Well, not for my class. I had a migraine. I called it off.
I just hate it. I'm glad in the first place.
Here, I'll turn on while I'm walking over here. I'll turn on the board camera. Hopefully, you guys aren't one of those kids that freaks out when did you all see Incredibles 2? You made it through that. We're fine.
Good camera quality.
Yeah, I know. It's a free one. You know what I mean? I got it from school. Mine is defective. I hope that's not normal. But I'll replace it with mine from home, and I'll take that one. My one at home is a wide angle. This would be better for this purpose. How was remote Wednesdays? Worst day of the week, best day of the week? What is it?
It's always bad.
It's always what?
Bad.
But you're home.
So,
Interesting. Keep hearing this. How do you feel about remote Wednesdays?
I don't like to do any of it because some of them give you big projects throughout the week and then you don't have to do it. So
You guys feel like you have more homework than usual? Okay, I keep hearing that.
It's not last year. Last year was a little.
Like,
Last year was
last
terrible.
spring was even worse?
Yeah.
Okay, so it's better than last spring.
Oh yeah.
Okay, good.
Yeah.
Okay, interesting.
High school was terrible last year.
I just want to figure out, like, what the kids are thinking and saying, you know?
I just sleep all day, so it doesn't really matter.
What, you guys think the portfolio's alright?
Yeah.
I mean, yeah, okay. It's not like, oh my god, another project. Okay, like, I want you working on it and, like, thinking about math and doing stuff, but I don't want it to be like, oh my god, what am I doing? This is stressful, or, oh my god, I have to work on this every day, you know? If you haven't done anything like 3 or 4 days, I might send you an email and be like, hey, everything alright? You know what you're doing? Stuff, no, but it's not like, if you don't turn it in 4 days and you're, you know. Anyway, if you haven't met with me, although I think all 3 of you have, but people online, if you haven't met with me for portfolio reviews from last week, I mean, you need to meet with me soon, and then you're going to meet with me next Wednesday along with the 8A people. Make sure that you're good to go.
We have learned classes next week.
We do. We go to 2:30 schedule, right? How you feel about that? What's that? Gotcha. So
I might
just in
switch
general,
online.
anti-school.
I might switch online.
For real?
Yeah.
What's that?
But,
Oh, really? That's gonna work in your schedule a little bit better?
yeah.
Alright. What about you? 2:30 schedule, who cares?
I don't get why they're changing it in the middle of this.
I mean, is it just general sentiment of like less time in school is always better? Is that the kind of feel? Yeah, I understand that. I understand that.
I think they should change it like after Christmas.
Yeah. Yeah, I don't know what's gonna go on. We're switching
After-
after more time in the classroom right
After
after
winter
season
break.
starts up. And you two weren't here last year, but we had like a flu epidemic. I don't know if you did it.
Oh, I got killed by it.
Yeah, like
I almost
everyone
died.
had the flu. Like this is before coronavirus. This is in December, I think, or
Yeah.
November.
November, yeah.
No, end of November, beginning of December. Vanderbilt was walking around with a face shield.
I had it in March when my mom did. She gave it to me.
Sure. Yeah. I remember this. Yep.
I died.
So I'm sorry. Yeah. So hopefully, like, so the way things work, as far as I'm aware, is that if someone has COVID-like symptoms, which are like symptoms of a cold, symptoms of strep, you know, there's a lot of overlap. Then, you know, we got to act on it. So it'll be interesting to see how that plays. Not sure how long we'll be able to. Like I said last year, even with you know, the flu and stuff was difficult. Because that's just what happens. You get people together, right? You know, it's not as bad at kindergarten, right? They come up to hug you, like, oh, I'm so glad to see you. Like, okay, side hug first of all, but yeah, cool. And then they're like, with their little noses, right? Human napkin. You guys aren't that bad. I know the camera's glitching. It's because it's the crappy camera, but I'll switch over to this.
I think there's some beef going down in the chat.
There's a bee?
Oh, beef.
Oh.
I think there's some beef going down.
Yeah, it's the camera glitches, guys. Sorry.
The camera's great quality.
All right, it is, but it's okay. You know what? Free is free, right? I'm glad I have it, and I'm glad teachers have it too, because in theory they could use it to, and theirs won't be defective, hopefully, right? In theory, teachers can use it to teach live, which I think is better than here's an assignment, have fun, right? But that's just me. So I'm glad we have it. Better than nothing. Let me take attendance real quick. Looks like, did I see Nevaeh yet? I don't see Nevaeh. I see Cliff, Max, Lindsay, Steven, Josh, Carter, Tickler, and Rowan. I do not see Nevaeh. Oh, hey, Cliff. Yeah, we need to get you caught up, man. I don't know how you want to do that. Pete, again, if you didn't hear the announcements at the beginning, if you haven't met with me for portfolio stuff yet, that means you're really behind the ball and we got to get you caught up. So I need to meet with you this week and next week on Wednesday. Wednesday will be another grade for 8A people. For B-Day people, it won't be. So 8A people next Wednesday. Okay, have stuff prepared for me. We've talked about how addition, subtraction, multiplication, one of those, right? The square / rectangle / other shape problem we did the other day, right? Okay. If you yeah, you were. If you what was I gonna say? I'm just gonna move on. All right, so today I want to talk about this concept and just see if you guys can figure it out. There's some puzzles. We talked about segment addition postulate the other day, which says that you can take a line, break it up into pieces, and if you put those pieces back together, no matter how you do it, right, it'll still be the same length as before. This should not be shocking to anybody, right? I'm going to give you one that's kind of boring, and then we're going to get into one where you're going to go, okay, what? And it's going to confuse you. So first of all, let's just talk about this concept. Just because I put a dot here does not mean that dot is in the middle of this line segment, okay? It's just a drawing, right? I mean, what is it? What's the line?
Take it easy, it's just a drawing.
Right, the Doodle Bob episode, right? Noi me, yay, right? You know what I'm talking about. So, not necessarily in the middle. However, if you notice that things line up vertically like this, you're allowed to assume that they do. Is that fair?
Who is that?
It's Parker. Who is not in this class. He's actually supposed to be in whatever his next class is, but I love that he's here. Making up for all the last time that you weren't here. It's also easier to talk about things if we label the points. So, Maddie, what's your favorite letter grade? There's a B? Okay, what's your second favorite letter grade? Oh my god. This is how normal class works. I wait for you to answer like the thing I want. Isn't that fun? This is student choice. Okay, no one's having fun with this. Every class has done A, B, C, D, more or less, and then we get to this and they say O.
F plus.
Every class, I swear to God.
F plus. E.
All right, so this makes it easier to talk about stuff, right? So before we even do anything, let's talk about relationships. What relationships do you notice here?
Well, A, B, C is parallel to D, E.
Ooh, they are. They are. They do not intersect. That's true. The way we can write that is we can say A, C, just call it the whole thing, is parallel to D, E. That's true. What else do you notice? That's a little simple for parallel. Very imaginative, these math people, right?
See here.
What else do you see? That's all you see? Come on. I feel like it's an ugly episode and it's SpongeBob and Patrick and he's holding SpongeBob and he's like, look at it! Look at it! Look at it! Look at it. What else do you see? Let me see if I'm getting some emails from kids that can't get into class or something.
They're the same line.
They're the same line. What do you mean by that?
Well, looks to me that they're the same length.
Yes, indubitably. They do appear to be the same length. We can tell very easily. If you, for instance, do you know the length of these pens? No, but they're smaller than my yacht. I have two. If you hold them up next to each other, you can see. Oh, wait, I'm not on the screen. You can't see anything. You ever seen David After the Dentist?
No.
It's very funny. It's this kid that goes to the dentist and he gets like the gas. And afterwards he's like, is this real life? I can't see anything. And his dad's like, you can see something. You're fine. And he's like, am I in heaven? And they're like, no, buddy. Right? It's just a very funny clip. We'll have to send it to you. Anyway, here we are.
I think you need to get a bigger green screen.
Well, if I go slightly bigger, then I have to put on a whole nother piece, and it makes it like twice as long, and I kind of don't want to do that. Two pens. We don't know their length, right? But we do know they're the same length because look, they line up. That's how we measure things, right? Right? You stand back to back with your friend. You try to figure out who's taller, right? Fun stuff. Fun stuff. I never got to do that because everybody knew I was shorter. No one ever was like, Derek, stand back to me. Let's see who's taller. Nobody. They already knew. So we know that AC is the same as DE. Do we agree with that statement? I like it. Okay, cool. What is AC also the same as? What's another thing that AC is the same as?
AB.
AB. Agree or disagree? AC is the same as AB. Disagree. What is it the same as? AC is the same as?
DE.
DE? Already said it? You already said it. This guy's funny. I was worried there wasn't going to be a funny kid in this class this year, but we got one. We got him. We got him. What else you see?
AB is the same as BC.
AB is the same as BC, so you're assuming that this point is the halfway point?
Yeah.
Didn't we talk about earlier how I just put a dot down and I did this?
Take it easy, it's just a drawing.
I didn't get out a ruler and be like, okay, let's make sure that's the middle, right? It'd be much easier to put the point down and say, hey, by the way, this is the same as that, just so you know, right?
It appears to be the same.
It appears to be the same. It looks to be deceiving. AD and CE are parallel. AD and CE are parallel. AD and CE. AD and C. Oh, okay, sure, yeah. I actually drew those in for you guys, but that's true. They would be. That's true. I'll write that down. AD parallel to CE. Letters are hard, guys. Sorry, I just like glitched there. CD and AE. Dang, girl, that's saying a lot. Crisscross, is that true? How do you know that? So these are parallel, which means these lines would have to be the same? If I were to draw, and she's saying if I were to draw on a line here to here, right? How do we know that to be true? Like, why does it matter that they're parallel? But why does the diagonal? Interesting. Well, if I were to draw a line from here to here, wouldn't I basically just make like this a triangle? Right? I would. And wouldn't you agree that this is the same length as this? It has to be, and these have to be the same length as well. So if these are the same length, and this is a triangle that has the same length as this top triangle, right? Imagine, let's draw on one of the lines. We have two triangles, and they're sitting right above each other, so there's like a 90-degree angle going on here. This is the same, that's the same. Wouldn't the diagonal be the same for both? Well, they share it, right? So both triangles have the same diagonal.
They should be the same.
Now what about this? What about this triangle? Doesn't it also have a 90-degree angle?
It's the same length.
It's the same triangle as this triangle, isn't it? Because they share this side, right? So this triangle has a CE, and this triangle has a CE. And we know that DE and AC are the same, right? So we know that this diagonal and this diagonal has to be the same. Because they're the same triangle, right? Even though they don't overlap, the red and the blue this time, they don't overlap, but they have to be the same. If two of the sides of a triangle are the same, then the third side kind of has to be too. That's a good conjecture. We're going to talk about that probably second semester. maybe the end of first. Okay. What if I wanted to know the length of AC? And I told you that DE has a length of 3x plus 3. And I'm using variables here because if I use regular numbers, it's really boring, right? If I told you that's 5 and that's 3, the whole thing's 8, right? Can we just skip that step? We know if I told you that's 5 and that's 3, then we know this is 8, right? Can we skip that? Okay, I'm using variables. Makes the problem a little more interesting. Well, you said AC and DE are the same thing. Well, isn't AC and DE, don't they have values now? Well, DE is just 3x plus 3. So instead of writing DE, I'm going to write 3x plus 3. What can I write instead of AC?
X plus 5.
X plus 5 plus 10? And the reason he's saying that is because isn't AC just the same as AB plus BC? It's the sum of its parts, right? And AB, of course, is X plus 5. And BC, of course, is 10. Take a number, add 5, add 10. Isn't there an easier way to say that? Why do I need two separate steps? Take a number, add 5, and now add 10. What could I tell you instead?
X plus 15.
Yeah, X plus 15, right? And again, we don't need the parentheses. It was just organizational to show you that, look, this is AB, that's BC, this is DE.
This is algebra.
Yeah, I mean it is, but we're not treating it like algebra. We're thinking about math. We're not doing it. Now, what does this mean? A number plus 15 equals that same number times 3 plus 3. Okay, hold on. Something plus 15 equals 3 times something plus 3. This is kind of a complex statement, isn't it? We need to look at this statement in an easier way. We need to turn the Rubik's Cube a little bit. We're not changing the Rubik's Cube. We're not taking it apart and sticking it back together. That's not allowed. Because if you do that, you might put it back incorrectly, and then, right, then it doesn't work. What we need to do is look at this in a different way, get a different perspective. Without changing the problem, see it in a different light, because this is complex. Now think about it. If I've got a truck full of something, and I add 15 to it, and I've got a truck full of something over here, 3 times the truck plus 3, right? I can kind of ignore one of those trucks, right? Wouldn't 15 just be the same as 2 of those trucks plus 3? One more truck would just be 1 more truck plus 15. I'm going to say that again. A truck plus 15 is 3 trucks plus 3. Well, wouldn't 2 trucks plus 3 just be 15 then? It's kind of a hard statement.
2 trucks.
Yeah, so if I've got a truck plus 15, right? And I've got 3 trucks plus 3.
If you get rid of that one.
Yeah, right? We can ignore one of the trucks on both sides, right? I don't need to look and count how much is in that truck, right? I don't need to figure that out because, look, they're just going to cancel each other out, right? All I really care about is how much is in the 2 trucks. Well, the total in the 2 trucks will be this, right? 2 trucks plus 3 will get you 15 because 3 trucks would get you an extra truck, right? Are you sort of seeing what I'm saying there? Really what we're doing is just PEMDAS. I'm subtracting x from both sides. And I'm allowed to do this because, remember, normally in non-COVID times, what I do is I pick 2 dummies in the front and I slap one in the head like this and I say, if you do that, it's child abuse. And then I slap both of them at the same time, but I say if you do it to both sides, it's algebra. Totally allowed. So as long as we do it to both sides, it's fine. That's the rule. This will hold up in court. We get 15 equals 2x plus 3. So 2 trucks plus 3 gets us 15. 3 trucks plus 3 gets us 15 and another truck. Right? You smell what's happening? It's extraneous. We don't need that. We can think of a simpler problem. Now we've got something plus 3 is 15, right? What plus 3 is 15? Something plus 3 is 15. No. You can do that if you want. But something plus 3 is 15.
And
What plus 3 is 15? 12. So 12 is plus 3 is 15. So in other words, that something must be 12, correct? So I'm going to write that down. That something must be 12. We cool? Something times 2 is 12. What must this something be? 6. Now, we thought about it, but if you were doing PEMDAS, you would have done the same thing, right? You would have subtracted 3 from both sides. You would have gotten 12 and 2x. Then you would have divided 2, and you've gotten x equals 6. It's the same thing. That's where PEMDAS comes from. I just prefer to think about it while we do it. So x is 6, which is the key to unlock all this, right? Because now we've got 11 and 10, which is 21, and 6 times 3 plus 3 is in fact 21 as well. So it works out. Not too bad, right? Not too bad. Are we seeing the connections here? The pieces add up to the whole thing. The whole thing's the same as this guy. That gives us a relationship. The pieces equal this guy, right? We're just switching stuff out. That's what we're doing. Are you ready? This wasn't too bad. Now I'm going to give you one that's going to take some thought. Question. Does putting those dots there tell you that I divided the line in 3?
no.
It could be, but not necessarily, right?
Yeah.
Right? It could be like, this one's really small and this one's a lot bigger, right? It's just a drawing. Then we've got this. Notice how these dots line up, right? What do I want to do here? What was the problem that I had? Ah, yeah, okay. Okay. So, I'm going to tell you the middle part here is 6x, and I'm going to tell you the whole thing here is 19x minus 1. I'm going to tell you that this is 14x, and that this is 10. And you're going to focus on those numbers because that's how your algebra smooth brain works, right? Well, what's the question? I ask the questions. Let's talk about this. Give it some labels. That way we're good to go. Instead of using H, I'm going to skip. And I'm going to skip I because they kind of rotate to look like each other, right? I'm going to go straight to J, K, K, L, and M. My question is, AD. That's what people say to me on the street. AD. And I go, what? What is AD? That's what we want to know. All right, tough problem, yeah? Anybody have the answer right off the bat? No. Okay, so tough problem. So tough problem. Let's not worry about the problem. Let's worry about relationships. Let's try to find easier questions to answer, right? Is that legible? Can you guys see that more or less? Okay, I'll try to use markers instead of pens. What do you see? What relationships do you see?
I got it.
What do you see?
Parallel.
They're all parallel. Very good.
The one thing I know.
Yeah, you can assume that. They're all parallel, even though they don't look like it. We'll say they are. What else do you see?
AD is parallel to LM.
AD is parallel to LM, so all of them are parallel, including the individual ones, yes. What else do you see?
I don't get how that makes sense.
Why?
Because EF and JK are about their look. If you slip JK over, it would be the same length. So
well, that's assuming that AB, BC, and CD are all the same length, right? Remember, AB could be shorter than this, and so that could make this shorter, right? I don't know.
Okay.
We don't know for sure. I'm glad you pointed that out, though. Looks can be deceiving. What else you got? A lot of diagrams don't go out of their way to label every single thing because then it crowds the diagram. And so they just rely on you to see the connections, right? They might tell you this whole thing's 20 and then not tell you that this is 20, right? On a diagram for something, like if you're an engineer or something. You just gotta be able to see the connections. So Lily says 10 plus x, or 10 plus 14x minus 6x equals 19x minus 1. Okay, let's write that down and see what she's saying, because I'm not sure. 10 plus 14x minus 6x equals 19x minus 1. All right, Lily, wait. No. What is she saying?
Oh, I got it.
What? What's going on here?
So the 14 minus 6 would be 8.
That's true.
And then you got the 10.
Yeah.
Oh, wait, no, I thought the 10 and that.
That's okay. Don't think about the algebra, think about the meaning. What is she saying here? Why is this true? If it is. What's going on here? What's her thinking, you think? Lily, no answering.
I thought the 10 had the X. So I thought it was 10.
You were going to put them all together?
18. Yeah, I thought it was going to be 18
Yeah.
X, but then it had the 19.
Right, so common mistake is 19x minus 1 is 18, right? Don't forget your x's. Stalk them on Instagram, okay? This guy has x's, this guy doesn't. It's apples and oranges here, okay? The two cannot mix. It's like I've got 19 chickens and I subtracted an orange. Okay, great. That doesn't mean you have 18 chickens. It also doesn't mean you have 18 oranges. It means you have 19 chickens and you took an orange away, right? They don't go together. Now, chickens and chickens? Oh, okay, sure. But before we get to simplifying, let's think about what she's saying here. Because she could have just said, if she wanted to simplify, 10 plus 8x equals 19x minus 1. But why did she say it this way? What is she trying to show? What's her thinking?
Show them step by step.
10 is this. 14x is this. There's a 6x here. What's going on here? 10 and 14 added together, but subtracting the 6x. Yeah. E to K is the same length as A to D. You dig? But see how they overlap? And she says they overlap by 6x. Right? See that overlap? Now, how do we account for that? Well, she's saying I can add 10 and 14x together. But since I overlapped, I only want to count this much once, right? Right now we're counting it twice. Do you see how we're counting this area right here twice? And we only want to count it once. So what do? We take out that area once, right? But now we've got this much plus 14x, of course, is this. So that's what's going on here. It's EF, can you see what I'm writing? Good. Plus JK but minus the part that overlaps. And we only subtract it once, right? Because we do want to count it once. We just don't want to count it twice. Nice job. And then what is 19x minus 1? It just looks like LM. Rad. EF is the same thing as 10, right? They're interchangeable. It's like Mac and Derek. I go by both names. If you see it in a sentence where it says Derek, you can replace it with Mac. It would make just as much sense. EF in a sentence can be replaced with 10, right? They are one and the same. That's what equal means. Okay? Don't forget that. Equal means they're interchangeable. It's a huge lesson to learn early on. You're going to think, easy. How hard could that be? But you're going to forget it. And that's going to get us LM. Cool. Well, now that they're all in their X form, right? They're like value forms, we can figure out what their value is, right? We can figure out what X is. So, Skylar's right. 14x minus 6x, that's apples to apples, right? If it was minus 7, how many X's would I have? So if it's minus 6, I'd have 8. 10 oranges play 8 apples, great. Neither do they don't mix, right? We leave them alone. So now we're here. We're going to do a thing that's a terrible idea in real life, but a great idea in math. We're going to get our X's together. You know what I'm talking about? Getting your X's together, right? It's like awkward. You're there. They show up. It's like, oh, hey, Samantha. Oh, Jenny. Hi. And Samantha's like, how you know Jenny? And Jenny's like, how you know Samantha? Like, oh, you know, like, Jenny's from the block, you know? Like, so it's like, Jenny is like my best friend. Did you guys date? And you're like, right? We're gonna get our X's together, guys. Aren't you excited? This is gonna be so much tension. All right. Our X's are on two different sides. How are we gonna get them together? Right. We do the PEMDAS thing. We're subtracting 8x, right? 8 trucks plus 10 is 19 trucks minus 1. Well, look, man. Can't I just write it like this? That means 11 trucks minus 1 is going to be 10, right? Because 8 more trucks is going to get you just 8 more trucks, right?
Then you add the 1.
Then we add 1 to both sides.
11.
Because what minus 1 is 10? What minus 1 is 10? 11, right? So the what must be 11. Do you see how that's basically PEMDAS? And then, yeah, I need to stop doing that. My X's look like Z's now when I make them all cursive-y. And then what times 11 is 11? Well, 1, right? Which is just PEMDAS, right? All we did here was we subtracted 8x to both sides, right? Which got us this. Then we added 1 to both sides, and then we divided by 11 to everything, right? When you multiply or divide, you have to do it to everything on the side. I think a lot of kids get confused about that. Because when you minus something or add something, you only do it to one thing, right? See how I did the minus 8x to this? It didn't touch the 1. And the minus 8x to this, but it didn't touch the 10. When you add, or when you multiply or divide, you have to do it to everything on both sides. Does that make sense? You got it. You got to take a big division bar and be like, divide everything by 11. Divide everything by 11. But most of the time, it's just one thing. So you guys get in the habit of just doing it to one thing, because that's all there is. Make sure you do everything. X is 1. Okay, great. X is 1. How do we solve a problem like Maria? AD.
Well, AD is 18.
AD is 18 because this is 18, right?
Yeah.
That means the whole thing is 18 up here. Awesome. Not bad, guys. Not bad. How do you feel about that one? Feeling okay? What's another way to solve it? What if I wanted to figure out this piece? How could I do that? Because we found the whole thing. The whole thing was 19 before, or 18 before, right? But how would we figure out that piece? What relationships do you notice? Don't worry about answering my first question. How do we figure out AB? What relationships do we notice about AB and the rest of this?
Takes out a chunk of that.
So in other words, AB and BC make up EF, correct? Or you could say EF, subtract AB, gets you BC, right? Two ways of looking at it, right? Take EF and take out a chunk, you get this, right? Or take the chunks and add them up. It's the same sentence, just a different way of looking at it. And you can see the PEMDAS here, right? Subtract AB to both sides, we get BC equals EF minus AB, right? That's all PEMDAS is, different way of looking at it. Sometimes when you look at it in a different way, it's easier to solve. So either way you want to look at it. Now, EF is 10, yeah? AB we don't know, BC is 6x. Remember, another way is that we can subtract and we get this. AB would be 10 minus the 6x, right? In other words, AB is 10 minus this piece, right? We digging that? Okay. So we can't do anything more with that right now, but we might as well write that down, write that down, write that down. That's how long that is. It's whatever 10 minus 6x is. Do I know what it is yet? No, but it's whatever it is, right? We cool with that idea? Writing that down? It's okay for something to be an expression and not be a nice number. It's whatever 10 minus 6x is, right? That's what you were saying, Skylar. This piece is just whatever is left over after you take away 6x. Okay. What about this piece? Let's use yellow. See how that shows up. Not bad. Kind of. I have a highlighter. It's kind of crappy. How do we figure that out? What relationships do you notice?
Look up. Yeah.
GJ. GJ. Like GG. AB equals half of EF? Yeah, so Rowan, this is a common misconception. I didn't draw these dots in specific spots, so that B could be over further. There's a B. It could be over further. It just looks like it's half, right?
Take it easy, it's just a drawing.
Right? That's something that we're gonna have to get used to with these drawings. They're not to scale or whatever. If the points line up, then they're good, but see how this point doesn't line up with anything? Right? If this point lined up here and I told you this much was 5, then yeah, you'd know for sure that's half, right? But we don't have any of that. We just know B is somewhere between A and C, okay? Same thing with C, somewhere between B and D. We don't know if it's a third, a third, a third. It's gonna take some getting used to. That's one of the hardest things about geometry. How do you solve a problem like Maria? How do you find CD? You said it's half, or it's a piece of. We don't know whether it's half or not, but we know it's a piece of GJ, right? It's a piece. Because GJ equals CD plus BC. So in other words, isn't this is what's left over when you take 14x minus 6x?
Couldn't you also, for all of these, couldn't you also take chunk out of KL?
Yeah, you could, yeah. You could do KL minus 10 would be this. That's another way to write it. Nice job. You should write about this. All the different ways you can look at it. Take care. I'll see you guys virtually tomorrow, okay? Yeah. Bye. And then all three of those added up should be 19x minus 1. Let's spray down the desk. Bye, Lindsay. I miss you. Get it?
And Texas
Yes, it's on here.
I dearly love to be, but all my exes live in Texas, and that's why I hang my hat in Tennessee. Rosanna's down in Texarkana, always beat up with her broom. Sweet Eileen's in Abilene, she forgot I hung the moon. And Dallas Sons and Galveston somehow lost her sanity. And Dimples, who now lives in Temple's got the law looking
Sing along if you know the
for
words.
me. All my exes live in Texas, and Texas is a place I dearly love to be, but all my exes live in Texas, and that's why I hang my hat in Tennessee.
Talking about relationships today.
I remember that Frio River where I learned to swim, and it brings
Andrew.
to mind another time where
I see Jamie, I see Olivia. I don't see Lexi or Demi or Gage or CJ.
I go there each night, but I always come back to myself.
Lexi's here.
Daylight, 'cause all my exes live in Texas, and Texas is a place I dearly love to be, but all my exes live in Texas, and that's why I hang my hat in Tennessee.
Good morning, everyone. Okay, I'll stop making my X's cursive. I'm sorry. They look like Z's, but poorly drawn.
Oh man.
Today we're talking about relationships. How can you talk about relationships without having X? There's a joke there. Hi, Demery. It's not really a relationship unless you have X, which is why we're going to start with this. So, would anybody like to tell me what they notice, what relationships they see here?
They have X.
They do. But we're not going to talk about that.
Oh.
This is math class.
They're both aligned.
They're what?
Both aligned.
They're both lines. What else do you notice about them?
Start and end at the same point.
They start and end at the same point. What do you mean by that?
I mean, like, it's.
There's a lot of pronouns going on here, which I am for, don't get me wrong. However, it's clearer if you don't use the pronouns. Can you talk about, like, the specific segment by name?
C and E are in the same spot.
C and E are in the same spot. Aha! We can't assume that. That's totally valid. That is totally valid. You can always do that on a diagram. If they're presented like this, that's cool. So C and E are in the same spot. If you want, you can draw a little dashed line to make sure you know. What else? Who's talking to me? Was it Gina? No, it's not Gina. Okay. It's like ventriloquism, the class. I have no idea. I know it wasn't Logan because I didn't hear. Low voice. He's a growing boy. What else do you see? Mitchell, mask on, please.
A and B.
I don't want to be able to look at you while you're talking.
Oh.
Thank you. I can't handle the full face, guys. You gotta look at it enough. Give me a break. Now, what do you want to say about B? What do you want to say? There's a B? No. Now, what else do you want to say?
Well, there could be a B in D and E.
So you're saying that it drops straight down?
Yeah.
Okay, that's true. It would.
B equals 3x plus 3.
B equals 3x plus 3?
Yeah.
Why?
Because it's like directly.
Because it drops right down. That's what you want to say? Aha! Yeah. Ooh, so you're saying AC is the same thing as DE. And that means that 3x plus 3, which is what DE is the same as what AC is. What is AC? That's a 10. Yeah? X plus 15. Now, where are you getting x plus 15 from? Yeah, it's some number plus 5 and then 10 more, right? In other words, some number plus 15, right? Not blowing anybody's mind there? Okay. So segment addition postulate says you can take the pieces and add them up and get the whole thing, right? So we have the piece AB, which is x plus 5, and then we have 10 more for BC. In total, AC. Okay. I like it. We switched some stuff out there, and we kind of skipped some steps. We're saying that AC is the same thing as AB plus BC. Is everybody cool with that idea? Right? It's the same as the whole thing. And then AC is going to equal whatever AB is, which is x plus 5. I'm using parentheses so you know I'm doing a substitution. I'm switching out. We're going to do that a lot in here. Again, we call that substitution. When we have an equal sign, it means it is the same, meaning that it's interchangeable. So like, for instance, Mac equals Derek. That is who I am. In other words, whenever you see Derek in a sentence, you can replace it with Mac, and it would make sense, right? Wherever I see AB, I can replace it with x plus 5 because they are one and the same. Same thing with BC, I can replace that with 10 because they are one and the same. And then if AC is, don't need the parentheses, right? It's just organizational. That means we've got x plus 15. So I can switch that out, right? And switch this out. Parentheses are just for organization. Trust me, when the problems get more interesting, it'll be nice to wrap them in parentheses, okay? But we don't need the parentheses. It's all addition, right? Okay, so think about what this means. Something plus 15. Let's call the something a truck. I don't know. This seems to be working today. We don't know how much is in the truck, but we know it's a single truck. And all trucks have the same stuff in them, okay? A truck plus 15 more is the same as 3 trucks plus 3 more. Now, hold on. If 3 trucks and 3 more gets me a truck and 15, isn't that the same as 2 trucks plus 3 gets me 15? Now, hear me out. 3 trucks and some more gets me 1 truck and some more. Well, doesn't that mean that 2 trucks just gets me the amount that's left over? Right? We don't need to count those individual trucks on both sides because, look, man, they cancel each other out, right? I'm going to just count however many are in there and however many in there. 3 trucks plus 3 gets me 1 truck plus 15. So 2 trucks plus the 3 would just get me 15, right? Right? Is that making sense? 2 trucks and 3 gets 15 because 1 extra truck would just be 1 extra truck, right? We can ignore those. If you're sort of getting that, that's okay. If you don't get it, that's fine. What you probably would do is do PEMDAS. And you subtract x from both sides, right? Because for some reason, if you do it to one side, it's child abuse. And if you do it to both sides, it's algebra. Right? You know what I'm talking about, right? You walk up to a kid, Jackson, right? This kid up here, right? And we would do this if it wasn't in COVID. But I don't want to get him sick. So what I would do is I go up to Jackson. He'd clear his forehead for me with his bangs, right? And I'd say this. And he'd go, ow! And I'd be like, see, this is child abuse. But if I did it to him and Jordan at the same time, do it to both sides, it's algebra. Totally fine. And this will hold up in court. So as long as I subtract x to both sides, we're all good. Everybody feels fair and equal. And we get this, right? Now what does this mean? This means something plus 3 is 15. Ladies and gentlemen, something, that's this guy, right? Plus 3 is 15. What plus 3 is 15? What? Try again. What plus 3 is 15? You're trying to answer what x is. What plus 3 is 15? 5 plus 3 is 8.
Sorry.
You're thinking too hard. What plus 3 is 15? Something plus 3 is 15, right? That's what this means. Something plus 3 is 15. What do you say? 12. So the something is 12. Right? Has to be. I'm going to write that down. Write that down, write that down. Now we have something times 2 is 12. What's the something? The something is this. So something is what? 6. Yeah. That's okay. Numbers are hard. I'm not worried about this. I just want you to see the relationship. Okay? Whether you got it initially and saw the right answer or got it later, I don't care. So something plus 3 is 15. Well, that means that something is 12. And then something doubled is 12. Well, then the something must be 6, right? We just did PEMDAS. Right? Subtract 3 from both sides. Oh, you get 12 equals 2x. Oh, very good. And now we divide everything by 2 and we get it's 6. Right? We're just thinking about it. That's all we're doing. We're just thinking about it as we do it. You can do PEMDAS if you want. That's fine. So if that something is 6, then I know that something is 6, right? 11 plus 10, 21. 21. Forever 21. And you're like, this is boring, right? Okay, if you haven't caught on yet, it's not just something I do, but a lot of teachers start out with an easy problem that you're like, okay, I see the connection, I see what's going on here. Boring. And then they give you the next one, and it's the where are your gods now problem, okay? So this is the easy one. Are you ready for the where are your gods now problem?
No.
You feel like you thoroughly understand this, right? AB plus BC is the whole thing. The whole thing's the same as that. Yada, yada, yada. You see the relationships? Wonderful. Are you ready?
No.
Question. Just because I put these 2 dots here, does that mean I cut this line into thirds? Not necessarily. It could be. But it could be like this is actually smaller than this guy, right? We don't really know. However, we do know that these 2 dots line up. Are we cool with that? We also know that these 2 dots line up and that these 2 dots line up. And to be clear what I'm talking about here, what goes with what? This much is 6x. And again, we can't talk about relationships without talking about x. It's just part of it. If we did regular numbers, it'd be really boring, right? If I told you this was 6 and that was 8 and that was 4, you'd just be like, oh, that's 18. That's not hard, right? So I'm including x to make it a little more difficult. Make it worth talking about. This piece right here is 10. Do you like that blue? You know, what's your favorite color? Navy blue. Gina, which one of these best approximates navy blue? None of them? I'm sorry. The what? My cup does? My water bottle. Okay, I like that. I like that. That's creative. Maddie, what's your favorite color? Some type of blue. Okay, Some Kind of Blue. Kind of Blue is actually an album by Miles Davis. It's one of the greatest jazz albums of all time. How do you feel about that one? We'll call it 14x. No reason. I'm not trying to say you have like 14 x's or anything, okay? I wouldn't be saying that. I would not. How do you feel about red? Logan, is that your favorite color? Red? What's your favorite color? I'm running out of... Look, they already look so similar. Pick a different favorite... It's not your favorite color anymore. What's your new favorite color? Purple? Isaiah likes purple. Purple's the funnest color to say. Purple. 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 Remember I said earlier, where are your gods now? Where are your gods now? What I want to know. Can you show me? A little Tarzan action. Phil Collins in the morning. I'm not going to use H, because H and I look the same if you rotate them. So I'm going to skip straight to J and K and O. Free Shavakadu. Uh-oh. I've made Gina mad. She's putting my name on the list. That's not good. I made the list. Gina, I can't say your name if I see your last name without saying Gina Lie. Just like that. I hope that's what everybody calls you. Do you have a middle name? Shore with an S-H-O-R-E. I love that. Do you have a middle name? What's your middle name? Nicole? Gina Nicole Lee. It kind of kills it. I don't like your middle name. You have to change that. All right. I love when kids have weird spellings of the names, and I can go, do you know it's spelled wrong? Do your parents know? Do you want me to like write a note home? Do you want me to get that changed for you? That's embarrassing. I can't do that this year. Except for Nevaeh Strobe. What? Hold on a second. Say it again. Okay, you're going to have to explain that, because I don't see any AX on here. Hold on. I got to get the colors. 14X, and then what? So you're doing 14X minus 6X, is that what you said? And then you're adding 10? Okay. You're not allowed to explain what's happening here anymore. Somebody else has to explain what you're thinking. Troy Mitchell? What is he talking about? Why is this true? Or maybe it's not. We trust no one in here. Logan, do you know what he's saying? He's saying 14X minus 6X plus 10X should be this. Why does that make sense? This is kind of out there. What do you see? Put these two together. Why are we getting rid of the 6X? I mean, I know that's what he's doing. Guys, check this out. First of all, it's for you. It's for you, buddy. He noticed that if you add these two together, right, they're not going to add up to this. However, the reason they don't add up is because there's this overlap. You agree? Now, we want to count this overlap once, right? We just don't want to count it twice. See how it gets counted twice when we add this and this? So what they're saying is that if I add both these up but take out the overlap once, what we end up with is this plus this. And that's going to be the whole thing, right? Are you smelling what I'm stepping in? These two added together is too much, right? Because there's this overlap. It counts the middle part twice. But if we take the middle part out once, then we get the whole thing. That's really clever. In other words, we're saying EF plus GJ minus BC, because BC is the overlap, right? The amount that's overlapped. If we take BC away once, we'll only count that overlap part once. We won't count it again. And that's going to equal KL. Nice. Okay. What can we do with this? What do you notice? Y'all watch Winnie the Pooh, the animated series? You know, Gopher? Is that too old? Okay. Someone whistled like they're Gopher just now. Amazing. What do you notice? What do you see? I feel like I need the quote from SpongeBob, the episode where he's got the ugly, and Patrick has to like hold him up in the movie theater, and he's like, "Look at it! Look at it! Look at it." What do you see? What can we do with this? Yeah, Logan. Correct. Now, the reason we're allowed to put these together is because they're talking about the same thing. Do you see how they're both talking about X's? Right? We're talking about relationships today, guys. We're talking about our X's. Logan's got 14 X's. He's taking 6 X's away. Does that mean you're dating 6 of them now and they're no longer X's? What does that mean? I don't know. We don't judge. So now he's really only have 8 X's, right? 8 X's, which is a reasonable amount, I think. Some of y'all started dating in kindergarten. So now you only have 8 X's, which is always better. That's less X's than we had before. Now, along with this theme, great idea in math, but terrible idea in real life. What are we going to do next?
Get your X's together.
We're going to get our X's together. It's awkward. It's kind of weird. You got to know what you're doing. You know, right? You're walking in the store, in the mall. Samantha comes up to you and she's like, oh, what are you doing here? And you're like, oh, hi, Samantha. And then Jenny shows up and you're like, oh, crap. And Jenny's like, hey, what are you... How do you know Samantha? And Samantha's like, how do you know Jenny? And it's like an awkward situation, right? You got to diffuse this thing. So we're going to get our X's together. Super awkward. But as long as... Oh, what?
I said question, when would I ever be in the mall? Never.
When would you ever have X's? Boom! Got him! No, okay. Yeah, you're right. Being in a mall. What are malls? Do you guys... When's the last time you went to a mall? They don't exist anymore, do they? Last week? Gina, you went to the mall? You're going to the mall today? What are you going to the mall today for? Anything exciting? To spend way too much money on stuff that you like or stuff that you don't like?
Probably something I like that I shouldn't buy, but I'm gonna buy it.
Nice. Okay, we won't get into that. That's fine. That's fine. We all have self-destructive habits. Okay? That's fine. I'm glad you have money to spend. If you run into any of your exes, bad idea. But in math, we get in this situation all the time where we got to get these X's together. So 8 of something plus 10 equals 19 of something minus 1. Isn't that just the same thing as saying, look, man, if 19 of something minus 1 gets me 8 of that something plus 10, isn't that just the same things as 11 of that something getting me the 10? Right? It's the same thing, right? We don't need to count that 8 over here twice. You see how there's overlap? We're counting 8 of something twice. Why not count it just once and have it just be the 11? I don't know. Really, it's just PEMDAS, right? We're going to subtract 8x from both sides. And we're going to have 11 x's. Gina, is 11 x's a lot in your experience? You have no idea. Gina's not about that life. She's about going to the mall. So 11 of something minus 1 is 10. So something minus 1 is 10 is what this is saying here. Let's not do math. Let's just think about it. Something minus 1 is 10. What's something? The something must be... Something minus 1 is 10. What must the something be? Was that a duck? It's okay. It's okay. You can bring pets to school. Something minus 1 is 10. 11. So the something, which I said was this, must be 11, right? Because 11 minus 1 is 10, right? Something times 11 is 11. Well, the something must be 1, right? And now we can plug in 1 to anything we want and get their values. Cool. Now, I never asked a question with this problem. You guys just kind of jumped into it. That's fine. But what if the question was, how much is this? How would you figure that out? Ooh, Maddie's thinking. Yeah? 19x. Ooh, okay. So, I have to bust this out.
Take it easy, it's just a drawing.
Good God, why are you so loud? She is assuming, and we know what assuming does, this is fine, that these are all equal. And so she's saying, look, it's this thing divided by 3. And that's really clever if it were true. But do we know that it's divided in thirds? It looks like it, but it's just a drawing. All we know is that B is somewhere between A and C. Somewhere. It could be like here, it could be there. I don't know. I was lazy. I just plopped it down. Now that's something that we're going to have to get used to in geometry, because you're used to looking at drawings that are drawn perfectly. But we're not worrying about that. Okay? Is that all right? Okay. That's a really good idea, though. There is a relationship there, right? These three pieces do add up to this, right? Are they all equal pieces? We don't know. I'm sorry, but thank you. There's always someone that brings that up in each class, and it's important. It's an important lesson that we want to get out there, because it's gonna hit you again and again and again. You're gonna think that, oh look, they're all equal because they look that way. Yes, Logan. Oh, sure. Right, so now that we know x is 1, we can just plug that into everything and figure it out, right? This is 18 minus 6 is going to get us, right, or something. 10 minus 6 is 4. Right, that's fine, that's fine. Pretend we don't know that it's 1 yet. However, his logic still stands. Isn't this piece right here just what's left over after you take away the 6x? I'll say it again. If I take this and subtract 6x, don't I get what's left over? Right? That makes sense. So in other words, this piece right here is just 10 minus 6x. Right? So Maddie was using her logic of saying, look, that piece is just whatever this divided by 3 is, right? Which wasn't necessarily true. It could be true, but we don't know. But do we know for sure that if you take this and subtract this amount will be left over? Does it matter where b is? Will this always be true? If you take EF, which is the same as AC, do we agree with that so far? EF is the same as AC? Yeah? Well, what is AC but AB plus BC? Agreed? Right, these two pieces put together. And so wouldn't AB just equal EF minus BC? Right, it's EF, subtract BC, what's left over will be AB. Has to be. Doesn't matter how much AB actually is, it's just whatever's left over. We're not specifying anything. Well, EF is 10, BC is 6x. If we subtract them, we get what AB is. That's what AB is. Remember, when something is equal, it means it's interchangeable. AB is the same thing as 10 minus 6x. That's what this says, right? So let's call it that. It's 10 minus 6x. What is that? I don't know. All it's saying is that it's whatever's left over. Are we cool with that idea? Whatever's left over. Maddie, are you seeing this? Yes? For real? Oh, okay. I talk a lot, and I'm like, there's no way they have any idea what I'm saying. And when you say stuff like that, like, yeah, I understand, it blows my freaking mind. Like, I don't know. I don't understand me half the time. Gina, no smiling in math class. We're 5 weeks in, and now the sass? Wow. Wow. The back sass. Wow. What are you doing? I'm not looking at you, Gina. I'm looking past you. It is cold in here. Somebody asked me why it's cold earlier. Was it this class? For the record, I think it's because of the air conditioning. What about this? How would I find the green part? Logan, you're on fire. Go for it. He's the hot hand. It's the same dumb thing. Isn't it just what's ever left over from this, right? 14x minus 6x is this. Now, 14x minus 6x, I can put those together. Why? Because they're both talking about x's, right? It's not apples and oranges, it's apples and apples. 14x's minus 6x's is how many x's? Better question. What's 14x's minus 7x's? What? What's 14x's minus 7x's?
What?
14x's minus 7x's. Think about it. Yeah, 7. So what's 14x's minus 6x's? You saw a pattern, but it was the wrong one. 8x, right? Isn't KL the same thing as AB plus BC plus CD? You agree? So another way to solve this is to go and find the individual pieces here and then solve. So this is 19x minus 1. Oh no. There we go. AB is the same thing as 10 minus 6x. I'm not using parentheses this time. I'm just using color. Right? I could wrap these all in parentheses to kind of show you where they came from. Right? All of this belongs to that. But I won't. We'll use color. Can you imagine learning math without color? It's so easy to see where this stuff came from. I'm substituting. I'm switching stuff out. I know KL is the same thing as 19x minus 1, so I switch them out. I know AB is the same as that. I know BC is the same as that. I know CD is the same as that. And now I can play around with it. What do you notice? What do you notice about this? Logan. It's the same thing as before, isn't it? Right? We're going to do the 6 and the 8 and then get the 14. It's going to end up being the same equation. It's just a different way of looking at it. What do you notice about these two? Yeah, right? Taking away 6 of something and adding 6 of the same thing. Let's not and say we did. You guys ever hear that expression? You're like younger brother, younger sister, and like, let's get out the Play-Doh. And you say, let's not and say we did. No? You guys were never abused by your older siblings like I was? Well, good for you. Gina, are you the oldest in your family? No. Are you the youngest? You have brothers and sisters? They go to this school?
They're 10 years older.
10 years older. Oh my god. So they're like closer to my age than your age. That's wild. I have so many questions, but I really don't want to know the answers. Okay, so subtracting 6 and adding 6. Let's just not and say we did, right? $19 of something minus 1 gets you 10, but an additional 8 of the thing. Well, again, we know this to be true. We've got 8 trucks over there and 8 trucks over there. Who cares about them? 11 trucks minus 1 should just get you the 10, because the 8 other trucks are going to get you the 8 other trucks. In other words, subtract 8x from both sides. And then we get x is 1 again. Lots of different ways to think of this. This is whatever's left over from here and here, right? This is also a piece, not a third, but a piece. We don't know how much of the whole thing here. We also talked about how this right here is just these two added together, but without the overlap, right? So we can take out the 6x, so 10 plus 14x minus this overlap will get you the whole thing. I want to make sure you guys see that. Do you guys see that you can take out the overlap once and it'll get you the whole thing? Jackson, are you feeling okay about this? Or are you all right? Not so much? This has been a lot for you. You've kind of had to just jump in the deep end here. You do a little drawing. I think the numbers make you focus on them because you guys are trained to do that. And that can be a problem. So, will this plus this be the same length as that? No way, right? We know it's longer. Why? Because there's overlap. Now, Jackson, if I told you that I stopped right here, now would they be the same? Definitely. So when we add these two together, we added a little bit too much. How much? The amount that they overlapped, right? And we want to count this part of the overlap once, but we don't want to count this guy. See, we doubled it, right? We counted it twice. So what we're saying here is, see how these overlap? If we don't count this twice and only count it once, right? Then it would equal this. So in other words, 10 minus the 6x, that's how much this is, right? Plus this would get us the whole thing. Better? Guys, have you ever done those puzzles? These are really big in the 90s, and none of you guys were alive in the 90s, but they were like these optical illusion puzzles. I'm trying to find some. My grandpa had a bunch. They're called magic eye puzzles. And it's like a bunch of like crazy like psychedelic shapes. Like it looks like nothing. And then if you get really close to it and then pull away, a 3D like image will pop out of it. Yeah. Like a boat. You know what I'm talking about? You have some of those?
I don't have one.
Darn. Okay. It's like, uh-oh. Uh-oh. My camera just up and died. Hello?
Broken.
Come on, fix me. Mac.exe has stopped working. There we go. I'm back. I know, not as good as the old me. I get worse and older every second. Seeing the concept is important. The letters and the numbers isn't as much, but seeing those connections is key. One of the key things we talked about today is that looks can be deceiving. Just because they look like they're thirds doesn't mean they are. And then lining these things up to see what they are for measurement, right? Like, for instance, we talked about this the other day, right? Do you know how long these pens are? You have no idea, right? Take a guess. How long do you think that is?
About 5 inches.
5 inches. Let's see. Where's my ruler? Where's my... I have no idea what she's saying. Okay. Looks like, oh, 5 inches. Hey! Woo-hoo! Math class. We guessed it right. This is exciting. Your lives are boring. Oh my God. What happened school today, honey? Oh my God, you wouldn't believe. So even if we didn't know what these are, how long they are, we do know that they're the same length, correct? Because we can line them up. I feel like this is a very easy concept that's boring you guys, but you're going to forget about it. And you're not going to understand how to do these problems because you're going to be like, oh yeah, no big deal. It'll happen to you. If you feel confident about this, write something. Make your own version. I'll see you guys virtually tomorrow. If you haven't met with me for portfolio stuff, you need to do that. You'll also meet with me next Wednesday along with the 8A people.
I want to write about that.
Do it. Make your own problem. Write about it. Tell me why it is. Tell me all the different ways to look at it.
We have a portfolio this week.
We will Wednesday, but not today.
Okay.
Yeah, next Wednesday. Later. All those were around Doomer? Oh, those particular yardsticks. That's what you mean. I thought you were trying to... Y'all have a good remote Wednesday? Yeah? When I asked other kids about that, their response was, no. Like, isn't that the best day of the week? You don't have to be here. And they're like, no, it's actually the worst. Is that how you guys feel? No?
It's better at school than online.
Really?
I mean, I get it.
Yeah. Interesting. You know, because like the stereotype of kids is just like, you know, less school is always better. I'd rather just not be there. Who cares? But you guys care. I figured you guys did, but that's not the stereotype. Us back. 3 of us. Tiny class. I had a song of the day for my geometry kids. I'll play the song of the day for you guys. Get it?
And Texas is a place I dearly love to be. But all my exes
class. Talk about X's.
And that's why I hang my hat in Tennessee.
Haley gets it. He thinks it's hilarious.
Rosanna down in Texarkana wanted me to push her broom. And sweet Eileen's in Abilene, she forgot I hung the moon. And Dallas Sons in Galveston somehow lost her sanity. And Dimples, who now lives in Temple's, got the law looking for me. All my exes live in Texas, and Texas is a place I dearly love to be. But all my exes live in Texas, and that's why
Alright, I see Evan, I see Seba, I see Matt. No Haley yet. No Camden or Leah yet. Or Cameron.
Eagle Point Park in Clinton had extensive damage due to the recent windstorm. Volunteer crews are working to clean up over the next few weekends on Saturdays. Lisa, this is Rick Sandro, volunteers that earn Eagle Point, meet at 10 a.m. near the dog park. Contact Mark Cyphers for additional information.
Mark Cyphers?
Great if you could get a group of friends together and suggest. Part of the week, one-time work can keep someone's entire day. Have a great day.
Alright, so yesterday, or 2 days ago actually, feels like forever ago. 2 days ago we talked about how on this number line that I created, you can represent different relationships between numbers, right? And number lines are good for showing relationships. Ignore this little thing right there. Let me see if I can get this in projector mode. There we go, a little bit easier to see. Ignore the little parentheses thing here, the bracket thing. That's just me having to do that. Also the secret folder. Normally this is just a gigantic coordinate plane, and I had to do a bunch of stuff to make it look like this. The relationship we're showing is between A and B, and that A is B plus 5, right? So whatever B is, A is 5 bigger than it. So when B is 0, right, A is 5. We can show all the numbers that have a relationship of 5 by doing this, right? We can change the value of B to whatever we want. And then when we add 5 to it, of course, it gives us A, right? It's showing the relationship between A and B. The problem is that if we were to show all the relationships where all the numbers are different by 5, like 1 and 6, 2 and 7, etc., we'd have a number line full of things, right? It would just be a gigantic mess. And then if I were like, okay, now compare that to all the numbers that are separated by 6, well, that number line would also be a mess, right? And there would be no difference between them. So number lines are good for showing the relationship between numbers, but they're not good for showing the relationship between relationships. Obviously, the numbers that are separated by 5 are different than the numbers separated by 6, right? But on the number line, it's going to look the same. It's just going to be a bunch of filled in spaces. So what we had to do is we had to get this guy. The coordinate plane, right? Meow. What's up, Camden? Yeah, still missing Leah, Mac, or no, still missing Leah and Cameron and Haley. That's what we're going to take a look at again today. We talked about some other stuff. I'm going to do a quick recap because I know it's been a little while. I'm dropping some frames here. Hopefully everything's all right now. So we talked about how the equation y equals x plus 2 is just showing all the numbers separated by 5, right? Because we can rewrite that as y minus x equals 5. Remember, subtraction is distance, right? And if we graph all the points that are separated by 5, 0 on the x-axis, 5 on the y-axis, 1, 2, 3, 4, 5, right there. We also have 1 and 6 would show up. We've got 2 and 7, they would show up, right? Where's my nice ruler? It must be at home. and we get this line that shows all the possible numbers that are separated by 5. Any point on this line represents two numbers that are separated by 5. Like we said, we had 0 and 5 show up, we had 1 and 6 show up, we had 2 and 7 show up. And notice the pattern here, right? As x goes up by 1, y goes up by 1, right? So you can really easily figure out the next in the pattern, 3 and 8. You don't even have to think about it, right? Hi, Haley. And it's useful because if we want to think about all the numbers separated by, I don't know, 6, like we said, that'd be this. Well, 0 and 6 show up, 1 and 7, etc., etc. You'll notice very quickly that they're the same line except one higher, right? And that makes sense because they're all separated by 6 instead of separated by 5. Now, the reason they're parallel we talked about, I know, I normally do. I just don't have one this year. The reason they're parallel is because the relationship is the same. We have 0, 5, 1, 6, 2, 7. If I start on 0, I get 6 here, and then I go 1 to 7, then I go 2 to 8, right? See how they both increase by 1? As x goes up by 1, this goes up by 1. Same thing over here, right? So their slope of the line, the steepness, is showing the relationship between x and y. How does x relate to y? Well, as one goes up, the other goes up the same amount. And we talked about this equation the other day. 2x plus 1. Actually, let's start with 2x. Y equals 2x. Is there any subtraction or addition going on here? No, but if I rewrite it, can I get this? So, what? So what's the difference going to be between y and x? The distance looks like it's going to be 0. So if I start out, the distance between y and x is going to be 0. So 0 would be 0, right? No distance between them. But what's going to happen over time? Remember, the relationship is what this number is, right? There's a 1 in front of here, right? They all go up by 1. This one, it's the y value is going to go up by 2, whereas the x only goes up by 1. I'll show you that, right? If I plug in 0, of course I get 0, right? 0 times 2 is 0. But if I increase the x by 1, I get 2 for y, don't I? See how this went up 1 and this went up 2? The y goes up twice as fast as the x. That's what this means. There's no distance initially between them. But after a while, the y goes up twice as fast. Let me show you that on the number line. Again, number lines are good as long as we're not trying to show all the numbers that have that relationship. So our equation would be something like this. Right? Again, ignore the stuff in the brackets, guys. Notice that when b is 0, a is 0, right? No distance between them. But as soon as b becomes 1, notice how much distance they have between them. They're separated by 1. And that's what we have here, right? There's a distance of 1 there. 1 versus 2, right? Distance of 1. And then if it's 2 apart, if b is 2, now they're separated by 2. And if b is 3, now they're separated by 3. So the distance actually changes for this one. It can even go opposite way. B can be bigger or smaller. It's smaller here, right? And it's bigger here. So that times 2 really is a different kind of relationship, right? It's not a constant, hey, we're always 5 apart. It changes over time. Okay, thanks for letting me know. Still missing Leah. So if we were to graph this guy, it's going to be a different kind of relationship. It's not going to look like all the other lines, right? It's going to be different. If I were to graph this line right here, what does this line represent? All the numbers separated by what? 3. But it's going to be a minus 3. And the reason for that is because before, when we had this, x was the smaller number, right? X is 1, y is going to be 6, right? X is always going to be smaller. Here, it flips the relationship. X is actually the bigger number, right? If I plug in 10, y will be 7. So all it is direction, right? Y equals x plus 3 would be here. The distance it is here is how far the numbers are always apart. That makes sense, because 0, if you're on 0 and you tell me the other number, it's really easy to figure out the distance, right? What's the distance between 0 and 7? 7. What's the distance between 0 and 10? 10. What's the distance between 0 and, right? Super easy. So if you look at the distance here between 0 and wherever you are, that's always going to tell you how far they are apart, right? Leah's here. How is Leah here? You guys all hanging out? Oh, Leah is here. Thank you. I didn't see your stuff, Leah. Hi. But notice that 2x is going to be a different kind of relationship, right? The distance isn't always going to be the same. It's going to be a little janky, right? It starts off where there's no distance between them, right? But then over time, the distance changes. As x goes up by 1, y goes up by 2. As x goes up by 2, y goes up by 4. 3 gets you 6. 4 gets you 8. And on and on and on. And we get this kind of a line, which is very different than the other ones, right? Let me do that in dark. Let me do that in a pen or a marker. Easier to see. This is a very different line than the other ones. It's not constant distance. The distance is going to change. The relationship between x and y varies. Okay. Why do we graph lines? Why do we graph? Why do we do graphs? To what? To be organized. What do you mean? Ooh, it's easier to see. Do you know why they call it a graph, right? It's short for something. Graphics. Graphical, right? It's a picture. When I give you this, it's like, oh, okay, right? When I give you this, you can see what's happening. It's a visual aid. Graphs can be helpful, and when they're not helpful, well, then don't use them. But I think you can see the connection a lot easier between all these other ones, right? The distance, the amount of the distance is different for all these lines, right? How far they're apart, but they're constant, right? The distance stays the same. But for here, the distance is going to change, right? It's going to fluctuate by double. So graphing these things, there's always one way you can do it. Plug in numbers and see what you get, right? All these lines represent are pairs of numbers. All the pairs that are separated by 6, all the pairs that are separated by 5, all the pairs that are separated by 3, all the pairs that are separated by 3 where the other number is actually bigger, right? It just kind of flips it. Here, it's all the numbers that are separated by double. So 0 and 0, 1 and 2, 3 and 6, they're all separated by double. A much different idea. What if I were to give you this? I want you to think about what this means. Got to draw on our plane. Eventually we'll be using Desmos for most of my graphs, but for now I kind of want to hide the equation. And in order for it to pop up on here, I have to plug in the equation. Kind of defeats the illusion, right? So, what if I gave you a line that looks like this? All of these lines represent relationships. What is the relationship this is showing? I'll give you guys some time to think about it. So Kaylee, like before, all these lines were the relationship of they're separated by 5, they're separated by 6, right? How far it is away, right? You remember that from the other day? This one has a weirder relationship. It's separated by double, right? So you can kind of tell what relationships are what, right? Separated by the same amount, these 4 lines. Separated by double, that guy. What does this represent? What kind of relationship would that be? Let me put some tick marks in while you guys are thinking. What kind of relationship are we talking about here? Because all lines really are there to illustrate a relationship. What's going on here? It is horizontal. It will always be 4 for y. Why 4? It is horizontal. That's what makes it weird, right? Like none of these, they all had a slope, sort of, right? An angle to them. Steeper the slope, the crazier the relationship is, right? Higher up, the farther they are apart, right? But like, what does this mean? Oh, 3? Why 3? He says it will always be 3 for y. Say it again. So the distance is always 3, it looks like, between 3 and 0, right? Well, remember, the distance only checks out for 0, right? After that, this measurement wouldn't be the distance, right? Because we have 1 and 3. Distance is 2. So the distance isn't going to stay the same necessarily. It will start out as being 3 apart. So like 0 and 3 is what we start out as, right? 0, 3, that's this dot right here. What else do we get? It will always be 3 for y is what he's saying. What do you mean by that? The next coordinate would be 1, 3, wouldn't it? And the next coordinate after that would be 2, 3. And then 3, 3. So are x and y related? Does y care what x is? It doesn't, right? If I show you this line and I ask you, okay, if x is 11, what's y going to be? You don't even need to wait to hear what I'm saying, right? It's always going to be 3. Y will always be 3. That's what this is. So how do we write this relationship? Normally, there's a relationship between x and y, right? Here, x and y aren't related. They're not even the same equation. They're not related. The equation we're looking for is this. Dude, y is 3. It's 3. What is it? It's 3. Well, what if x is, it's 3? Does he care about x? Does he say anything about x here? No. Well, if you tell me x, I can tell you what it is, right? If you tell me x is 5, then I can tell you y is 2, right? No. It's 3. No one cares what x is here. So the equation of this line, how we'd write that is y equals 3, always. What's x? Anything you want it to be, man. You want it to be 0, get it. Y is 3. You want it to be 5, y is 3. X is anything. Nice job, guys. So if I were to give you this, does this line represent a relationship between x and y? Not a very good relationship, right? One doesn't listen to the other. Do you see what I'm doing here? I'm painting a metaphor. You know, relationships. You got your exes. They live in Texas. Exes. You see, it's very funny. It's very funny. It's not really a relationship between x and y, is it? All of these dots will all have something in common. What do they all have in common? Y is what? -1, always. That's it. Now, in regular math class, when they teach you slope, intercept, and all that stuff, they give you this and they say graph it, and you're like, what's the slope? Is that the y-intercept? I don't know. I'm confused. If you know what it means, it's so easy. Guess what? Y is -1 always. Oh, awesome. Let me color in all the points where y is -1. How about 0, -1? How about 1, -1? How about 2, -1? How about 3, -1? Oh, okay. I see the pattern. Question. What does this line represent? Remember, if it's angled, it means there's some kind of relationship between x and y, right? If there's no angle, it doesn't care about something, right? There's no real relationship. What do all of these dots have in common? This dot right here, this dot right here, this dot right here. What do they all have in common? Yeah, the x is always the same. It doesn't care what y is. Y could be anything, right? Y is the vertical. You can go anywhere up and down on here. Y can be whatever number you want. Y could be 1, it could be 2, it could be 3, it could be 4, it could be 1,000,000, it could be -5, right? But x will always be what? 4. That's the line x equals 4. It's all the points where x is 4. Do you see any points where x is 5? No, because they'd have to be on here, right? Whoa. Personifying stuff makes it easier to understand. We are people that work on relationships. That's why you guys want to come to school, right? For social time, see your friends. That's why Wednesdays suck. Everybody stays home and you just got to do work. Boo. And you're with your siblings. You got to babysit them. Are you the youngest in your family? Oh, so you're the baby. Got it. So you're the annoying sibling. What about you? So you got to babysit them all? Yuck. I had to do that while my parents were going to grad school. They were both teachers and they went to grad school at the same time to get, you know, more education. Because if you don't get more education, you can't stay a teacher. You got to get education every now and then. And so like every Tuesday, Wednesday, and Thursday they'd be out. And sometimes Mondays and Fridays. And so it'd be like, okay, kids, what are we doing today? I had 2 younger sisters. Throwing in a Jack's Pizza and turning on SpongeBob. Best babysitter ever. I'm going to go upstairs in my room. Leave me alone. Yep. So what once was like a weird problem that people would give you, right? Graph x equals 4. You're like, what? Now it's just kind of really easy. It's all the points where x is 4. If I told you to graph x equals -7, well, find me all the points that x is -7. Well, I don't know. How about -7, 0? How about -6, 0? How about 10, 0? Right? Any of those. -7, 1, 2, 3, 4, 5, 6, 7, 0. Done. -6, 0. 10, 0. What are you thinking? What's up, Zed? What are you thinking? And then this line would have to be where x is always -7. Agree or disagree? Is x always -7 on this line? It's not, right? Because there's -1, 0. There's -2, 0, right? Isn't the first number the x? I pulled a switcheroo on you guys. I've told you my first rule in here is trust no one, right? I have told you that? Okay, good. Then it's fair. I started off following the rule. Look, x is -7. I did it. It's right here. But then what did I do? I changed x, didn't I? This will happen to you. Another point that has -7 for x, well, would be this, or this, or this, right? As long as x is -7, it follows this rule. So -7, 9 would pop up. -7, 10, -7, 2, -7, -3. And you notice very quickly, that's what the line would look like. Isn't it weird that when x is fixed, right? X has to be -7, no changes. When x is fixed, we get a vertical line. But when y is fixed, y equals 3, y equals -1, y equals 0 is what this line would be, right? It's horizontal. It's kind of opposite, right? X, you think horizontal, right? But when x is stuck, the only thing that can change is what? The vertical. When x is fixed, that means we're not changing left or right, are we? Right? X is always -7. We're not moving to the left, we're not moving to the right, we're staying right on -7. What's the only thing that can change? The y, the vertical. And that's why we get that line. Some teachers will be like, oh, it's just the opposite. Remember that. And then you're like, wait, is it the opposite or am I remembering it wrong? Yeah, I guess you can. So, if you think about what it means, it becomes a very boring question. As long as you understand what's going on, right? These lines represent relationships. And vertical or horizontal lines, they don't care what x is doing. They don't care what y is doing. I'm stuck here. I'm not changing. It's stubborn. It's not going anywhere. That's the idea. Now, what if we took these ideas and combined them? We've talked about y equals x plus 5, right? That's all the numbers separated by 5. We talked about y equals 2x, where all the numbers are double, right? What about this? Bum, bum, bum! Well, if we look at the distance, we get this, right? So the distance initially should be 1, right? But then the numbers are going to change. So distance is 1. Oh, question. Which number is going to be bigger, the x or the y here? Yeah, because whatever this is, it's going to be double and add 1, right? It's twice as big plus 1. So the y is going to be bigger. If I plug in 0 here and plug in 1 there, 1 minus nothing is 1. Yep, that checks out. Y is the bigger number. We didn't change anything, right? Just because we move stuff around doesn't mean it's going to change the relationship. The relationship is still the same. The equation's still the same. It's just a different way of looking at it, okay? But then we know that the number's going to increase by 2 every time, right? So if I increase x by 1, this is going to increase by 2. If I increase x by 1, this is going to go up by 2. If I increase x by 1, this is going to go up by 2. Those are the kind of numbers we have. Let's graph that. So we know that the initial distance will be 1, right? So 0 is separated from 1. Cool. But then, as we go up by 1 in the x direction, we know we're going to go twice as much in the y direction. So as we go up by 1, we're going to go up by 2 here. Right? Y used to be 1, now it's going to be 3. X is 2, it's now going to be 5. X is 3, it's now going to be 7. This is the line we get. The line we had earlier was this line. They're similar, right? And we got this. Ah! The numbers we got for this were 0 and 0, 1 and 2, 2 and 3, 3 and, 2 and 4, 3 and 6. What do you notice about this? When it's just 2x, we get this. When it's 2x plus 1, we get this. What's the relationship that you see here? From here to here, I added 2, right? And that makes sense. As this goes up by 1, that goes up by 2. That's what we talked about, right? That's what this represents. As this goes up by 1, what does this go up by? 2 again. Oh, well, that makes sense because they both have a 2 there, right? That's relationship. Y is going to be twice as big as x. Y is going to be twice as big as x. It's just going to start 1 higher. Do you see how this one starts at 1, whereas this one starts at 0? So in other words, the number here is just kind of where your line starts. Like at 0, you're going to have 1, right? This guy doesn't have anything. So at 0, you're going to start at 0. But then after that, you just follow the pattern. Go up by 2 over 1. Oh, wait. Did I just say slope? Up by 2 over... Oh, I did. I broke the magic. That's all it is. Up 2 over 1, up 2 over 1. You remember that from algebra? All it's talking about is the relationship between x and y. They have the same relationship. This one just starts on 1. This one starts on 0. And then they go up by 2. If I were to give you this, what does this represent? This one started on 0 and then goes up by 2, right? The relationship is double. This one starts on 1 and then the relationship is double, right? It starts on 1, the relationship is double. 2 every time. Where's this one going to start? On 5. It starts at 5, 0, 5. But then it doubles every time. So 1 gets you 10, right? And 2 gets you 20. Wait a minute. 0 gets you 5. 0, yeah, that checks out, right? Plug in a 0, you get 5. If I plug in 1, do I get 10? No, I get what? Say again? Plug in 1 here. Two times 1? Plus 5? Oh. So what do you think 2 is going to get us? Not 20, but... What? 10? Why 10? Why your prediction? Don't look. Why is your prediction 10? 5, 7. Why 10? Not sure. He just said it. 9. And we can check that, right? 4 plus 5 is 9. So the amount we change in the y direction is 2 every time, right? That's what this means. But it just starts at 5. The amount we change is 2 every time. We just start at 1. The amount we change is 2 every time. We start at 0. So when I graph this, it's starting at 5. 1, 2, 3, 4, 5, right? And then the relationship is plus 2 every time. So as we go up by 1, we go over 2. As we go over 2, we go up 4. As we go over 3, we go up 6. And notice it has the same slope. It's the same steepness as the other ones. Because the relationship between x and y is the same. It's always double. It's just where we start changes. Right? Always go up by 2. Always go up by 2. Always go up by 2. That's what this number means. The only thing that changes is where we're starting. Start on 5 and then go up by 2s. 5, 7, 9. Start on 1 and go up by 2s. 1, 3, 5, 7. Start on 0 and go up by 2. 0, 2, 4, 6. What if I wanted a pattern that started on 8 and went up by 3s? I want to start on 8. So at 0, I'm at 8. And then after that, I go up by 3s. 11, 14, 17. What would the equation be that gets me that pattern? Again, start on 0, go up by 2. Start on 1, go up by 2. Start on 5 and go up by 2. I want to start on 8 and go up by how much? 3. Start on 8 and go up by 3. What would I write? Start on 8, go up by 3. Checks out. If I plug in 1, I get 3 times 1 plus 8, 11. If I plug in 2, I get 6 plus 8, which is 14, because that's 7 plus 7, right? 9 plus 8 is, yeah. Guys, that's all this has ever meant. And this is going to be weird and confusing, and you might not feel 100% comfortable with that yet, but that's fine, because we've spent, like, I don't know, like 15 minutes, 20 minutes on this. But yeah, we could just do, okay, well, the y-intercept's 8, and I go to 8, 5, 6, 7, 8, and then I go up 3 over 1, right? It's go up and then over, or is over then up, right? Or we can think about it. You can do both. But I think most math classes don't have you think about what it means. And I want you to be able to do both. Lily asks, why is slope y over x, but coordinates are x over y? Well, slope is rise over run. Do you guys remember that? Being told that? And we talked about the other day that rise is how much you go up, right? And up has to do with y, right? Whereas rise has to do with this. Yep. That's why. See you later. It's a convention. Take care. Hey, what's up, Eads?